Hey guys, tonight we're going to journey back to a time before the cold. A time when our planet was a stranger to ice, a lush, sweltering greenhouse world, to find out what it takes to start a 100,000-year pattern of global freezing. Imagine, we are 50 million years in the past, standing on the shores of the Arctic Ocean. But there is no ice. There is no biting wind. Instead, you're wiping sweat from your brow. The air is thick, soupy, and warm. Like a rainforest in the middle of a heat wave. Before you lies a swampy, humid forest of cypress, dawn redwood, and palm trees. The ocean itself is a balmy 20 degrees Celsius, about the temperature of a modern-day resort in Florida. In that oppressive warmth, a tiny creature rustles in the leaves. It's a small, lemur-like animal, one of our earliest, most distant primate ancestors, clinging to a branch in a place that will one day be buried under 3 kilometers of solid ice. It knows nothing of the cold. It knows only this endless planetary hothouse. Over millions of years, this planet will undergo the most profound transformation. It will shed this jungle cloak, piece by piece. The atmosphere will thin. The continents will drift into new positions. And slowly, surely, the first frost will appear. That frost will grow into a glacier, and that glacier will join others to become continental ice sheet, a power so vast it will grind mountains to dust and rewrite the map of the world, setting the stage for a completely new kind of life. And for us. So what does it take to freeze an entire planet? How does an Earth with alligators living near the North Pole become a world of kilometer-thick ice sheets? And is this freezing just a random accident? Or is it part of an ancient, predictable pattern, a clockwork built into the very bones of the solar system? Thanks to incredible, high-resolution climate records drilled from the deep ocean floor and from the heart of the ice itself, tonight we will piece together this grand puzzle. We will find the hidden pacemaker of our planet, the 100,000-year cycle that has defined our world and our own evolution. Frankly, if you were dropped here in this Eocene jungle without industrial-strength mosquito repellent and a serious antifungal cream, you'd be miserable in about 5 minutes. The humidity is 100% all the time, and the insects are the size of your thumb. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. That small click sends a big signal to the algorithm. That long-form, serious educational content still matters. And to me, it's an incredibly meaningful show of support. Thank you so much for helping keep this channel going strong. It always fascinates me to see where you're all tuning in from. Let me know in the comments where you are in the world and what time it is for you. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're standing in the Eocene epoch, a period that lasted from about 56 to 34 million years ago. To call it a hothouse is an understatement. This is a world without an ice coolant system. There are no polar ice caps, not at the North Pole, not at the South Pole. As a result, the planet's entire climate is different. The temperature difference between the equator and the poles is tiny. Today, it's a massive gap. Back then, it was just a gentle, warm gradient. You look at a map of this world, and it's almost familiar. The continents are closer to their modern positions than they were when the dinosaurs died out, but the details are strange and crucial. Australia is just beginning its final separation from Antarctica, which is still covered in temperate forests. North and South America are separated by a wide seaway. And most importantly, you see the Indian subcontinent. It's not a subcontinent yet. It's a massive island, a continental battering ram that is in the middle of the slowest, most powerful collision in Earth's history, slamming into the underbelly of Asia. As you watch, over millions of years, this crash is pushing up the first wrinkles of what will become the tallest mountain range on Earth, the Himalayas. This isn't just a scenic detail. This colossal act of geological engineering will fundamentally change the world's weather. But for now, the world is defined by warmth. The life around you is bizarre. This is the dawn of the age of mammals, but they haven't quite taken over. The true rulers of the forest floor are giant, flightless birds. You might see a Gastornis, a 2-meter-tall behemoth with a skull like a sledgehammer that stalks the forest floor. Mammals, for the most part, are small, scurrying things. This is the era of the first true primates, the first horse-like creatures, no bigger than a house cat, and the first bats. The truly weird part isn't just the animals, it's the plants. There is no grass. You are in a world before prairies, before savannas. The planet is covered in endless forest, jungle, and swamp. What's powering this global sauna? The air itself. You take a deep breath. It feels thick, and it is. It's saturated with carbon dioxide. The scientific evidence from deep-sea cores, from the chemistry of fossilized leaves, all points to one culprit. Atmospheric CO2 levels were somewhere between 1,000 and 2,000 parts per million. For reference, our pre-industrial level was 280 parts per million. This blanket of CO2 is trapping the planet's heat, creating the greenhouse effect on a massive scale. This is the baseline. This is the normal state our planet was in for millions of years. So, to understand the Ice Age, we first have to understand what ended this. How do you pull that much CO2 out of the air? Scientists still argue about what finally tipped the scales. Some point to the new Himalayan mountains. As this fresh rock is pushed up, rain erodes it, and the chemical reactions in that erosion process actually pull CO2 out of the sky, slowly, over millions of years. But there's a quirkier, more dramatic theory. It's called the Azolla event. The idea is that around 49 million years ago, the Arctic Ocean, which was then a nearly enclosed, stagnant sea, was covered by a sudden massive bloom of a tiny freshwater fern called Azolla. This super bloom may have lasted for 800,000 years. As these ferns grew, they sucked CO2 from the air. When they died, they sank to the bottom of the anoxic ocean, where they couldn't decompose, effectively trapping that carbon on the seafloor. This, the theory goes, was the first great carbon capture event, a biological pump that began the long, slow process of chilling the planet. Whatever the cause, the mountains, the ferns, or both, a change begins. It's impossibly slow, imperceptible. But the planet's thermostat is being turned down, 1 degree at a time. The hothouse is breaking. The long chill has begun, and it will set the stage for a new kind of world. A world ruled by grass and ice. We move forward in time. You leave the swampy, sweltering Eocene behind. The planet is changing. You're witnessing the Eocene-Oligocene transition around 34 million years ago. Geologically, it's a cold snap. It's not a slow, gentle decline anymore. It's a sudden, sharp drop in global temperature. The Earth, for reasons scholars still argue about, suddenly crosses a critical threshold. The exact trigger is a mystery. Was it the final separation of Antarctica, or a sudden drop in CO2 finally reaching a tipping point. Whatever the cause, the hothouse world shatters. This event, sometimes called the Grande Coupure or Great Break, is the real beginning of the modern icehouse world. The warmth-loving Eocene life is devastated. Forests retreat. The planet is becoming cooler, but more importantly, it's becoming drier. And into this new, drier world steps a humble, revolutionary new plant. Grass. It seems so simple, so boring. It's just grass. But its arrival is one of the most important evolutionary events in the planet's history. Before this, as we saw, the world was forest and swamp. Now, in the cooler, drier climates where trees can no longer thrive, this new, tough, resilient plant begins to take over. It creates an ecosystem that has never existed before: the grassland, the savanna, the prairie, the steppe. This isn't just a change in scenery. It's a declaration of war. Grass is not like other plants. It grows from its base, not its tip, meaning a grazing animal can chew it down to a nub, and it just grows right back, tougher than before. This is its survival strategy. As a fringe tidbit of evolutionary spite, grass also evolved to incorporate silica, the same mineral that makes sand and glass, into its tissues. It's essentially armoring itself with microscopic, abrasive particles. It is, quite literally, a dumb plant, in the sense that it is incredibly difficult to eat and digest. This innovation sparks a massive evolutionary arms race. The small, forest-dwelling mammals of the Eocene are forced to adapt or die. To eat this new superfood, you need specialized equipment. You see the rise of the first true grazing animals. Early horses, for example, evolve from small, cat-sized forest browsers into larger open plains runners. Their teeth change, becoming longer, tougher, and ever-growing hypsodonty to cope with the constant grinding wear of that silica-laced grass. You see the first rhinos, the first camels, the first ruminants, all of them evolving complex stomachs and specialized teeth just to survive on this new, abundant, but difficult-to-eat resource. And where the grazers go, the predators follow. The old forest ambush hunters are at a disadvantage in this open, exposed world. A new kind of predator evolves, the pursuit predator. The first dog-like and cat-like carnivores appear, built for stamina and speed, able to run down their prey on the open savanna. This is the new world order. This is the world that shaped us. As this grassy revolution unfolds, our own distant ancestors, the early apes, are still in the trees. But the trees are shrinking, the forests fragmenting. The world is becoming a patchwork of forest, and this new, dangerous, open grassland. The pressure is on. Some apes will stay in the shrinking forests, but one lineage, our lineage, will eventually be forced to adapt to life on the edge of these savannas, taking its first tentative steps out into the open. That pressure, that single evolutionary challenge, is what will eventually lead to us. Let's jump forward again, to the Pliocene, which begins about 5.3 million years ago. We are getting very close to the Ice Age now, but we're not there yet. The Pliocene is the planet's last great warm age, before the Big Freeze. It's still significantly warmer than our modern, pre-industrial climate. The scientific evidence from ocean sediments shows sea levels were, on average, 25 meters, 82 feet, higher than they are today. That's a lot of water. It means the coastlines you know are gone. Florida is underwater. Much of the Amazon basin is a giant inland sea. The Pliocene is a golden age of mammals. The arms race of the grasslands has produced a planet of giants. This is the first wave of megafauna, but these are warm-weather giants. Megalodon, the bus-sized shark, patrols the oceans. In Africa, our ancestor Australopithecus, like the famous Lucy, is walking upright, looking out over a savanna teeming with three-toed horses, giant baboons, and saber-toothed cats. In North America, you'd find herds of Teleoceras, a hippo-like rhino, and giant bear dog predators. The world feels stable, but one last critical piece of the Ice Age puzzle is about to click into place. You look at a map of the Pliocene. North and South America are still separate. A deep-water seaway, the Central American Seaway, flows between them, allowing warm water from the Atlantic to mix freely with the Pacific. Then, slowly, relentlessly, the Isthmus of Panama begins to rise. Volcanic activity and the crushing movement of tectonic plates push the land up from the seafloor. Around 3 million years ago, the connection is complete. The land bridge is formed. This event has two immediate, massive consequences. The first is biological, the Great American Biotic Interchange. Animals that had been evolving in isolation for millions of years can now cross over. Saber-toothed cats and mammoths move south. Giant ground sloths, terror birds, and armadillo-like glyptodonts move north. It's a colossal ecological scramble. The second consequence is climatic, and it is the single most important event that triggers the Ice Age we know. By closing that seaway, the Isthmus of Panama fundamentally reroutes the oceans of the world. Warm Atlantic water that used to flow into the Pacific now has nowhere to go. It's forced to turn north, carrying warm, salty water up the coast of North America. This new, powerful current, the Gulf Stream, is born. You'd think this would make the north warmer, and it does at first, but it also carries something else: moisture. This new Gulf Stream acts as a conveyor belt, pumping massive amounts of warm, wet air into the high northern latitudes. In the summer, this means rain, but in the winter, it means snow. Unbelievable amounts of snow. The planet was already cooling. The continents were in the right place. And now, you've just turned on the snow machine for the entire northern hemisphere. The stage is set. But before that snow machine in the north can truly take over, we have to look south. We've been following the story of the northern hemisphere, but the most important event that set the stage for the Ice Age happened millions of years earlier, on the bottom of the world. We need to rewind, back to the time of our Eocene hothouse, and look at the continent of Antarctica. Today, we think of it as a dead, white wasteland, a place defined by ice. But 50 million years ago, Antarctica was green. It was alive. It was still physically connected to Australia, and not far from South America. It was covered in lush, temperate rainforests of beech trees and ferns. You would have found possums, small mammals, and birds. It had a mild, cool, wet climate. It was a normal continent, full of life. But tectonics, as always, is patient. You watch as Australia, on its own slow-motion journey, breaks its final connection and begins to drift north toward Asia. A little later, the tip of South America tears away, opening up a final critical gap. This is the fringe tidbit that changes the world. Antarctica is, for the first time, completely, utterly alone. It's now a continent-sized island, sitting squarely on the South Pole in a state of splendid isolation. And this isolation has a profound, immediate consequence. With no other continents in the way, the ocean currents of the South are now free to do something they have never done before. Circle the entire globe, unimpeded. The Antarctic Circumpolar Current is born. This is the most powerful, most massive ocean current on Earth. It's a colossal, non-stop river of cold water, a moat that encircles the entire continent. And its effect is devastating. It's an impenetrable barrier. No warm tropical water from the equator can ever reach Antarctica's shores again. It is cut off from the planet's heating system permanently. And so, the freezing begins. This is the event that truly ended the Eocene hothouse. Around 34 million years ago, as this current switched on, the southern continent flashed over. The green forests died, and the first ice began to grow. This wasn't a slow creep. Geologically, it was a sudden, violent freezing. Within a few 100,000 years, a continent larger than the United States was buried under a permanent ice sheet, kilometers thick. This changes everything. It's not just that the South is cold now. The freezing of Antarctica creates a new, powerful force in the planet's climate system. Albedo. It's a simple concept. Dark surfaces, like oceans or forests, absorb sunlight and turn it into heat. Light surfaces, like white ice and snow, reflect sunlight straight back into space. The forest-covered Antarctica absorbed heat. The ice-covered Antarctica reflects it. You've just installed a continent-sized mirror on the bottom of the world. This is the scientific evidence for the Great Cooling. This is the birth of the positive feedback loop that will define the coming ice ages. The more ice there is, the more sunlight is reflected. The more sunlight is reflected, the colder the planet gets. The colder the planet gets, the more ice grows. This is the real beginning of the icehouse Earth. The planet now has a permanent coolant system. The entire global climate becomes more sensitive, more nervous, more prone to tipping. It's now preloaded for an ice age. For millions of years, Antarctica becomes the sleeping giant. It's a massive, mostly stable anchor of cold that keeps the planet's average temperature down. It just sits there, a sleeping giant of ice, waiting. It has set the stage. All that's needed now are the final, more delicate triggers in the north, like the formation of the Isthmus of Panama and its new Gulf Stream snow machine, to finally push the rest of the world over the edge and begin the rapid, repeating cycles of the Ice Age we are here to explore. All the pieces are now on the board. You have the planet in a preloaded cold state, thanks to the sleeping giant of Antarctica. You have the continents in their modern positions, and you have the snow machine of the Gulf Stream, pumping moisture into the high north. The Pliocene warmth is over. The long chill has reached a breaking point. And 2.6 million years ago, it happens. The system tips. This is the official start of the Pleistocene Ice Age, the one we are technically still in today. For the first time in Earth's history, large, permanent ice sheets begin to grow over North America and Scandinavia. The Northern Hemisphere flashes over, just as Antarctica had done 30 million years earlier. The great ice house is complete. But this is where the story gets strange. And this is where we find our first real mystery. When these northern ice ages began, they did not follow the 100,000-year pattern we are here to investigate. They just didn't. We know this from the scientific evidence buried on the ocean floor. By drilling deep sediment cores and analyzing the chemistry of tiny, fossilized plankton shells, Foraminifera, we can reconstruct a near-perfect history of global ice volume and temperature. And what that record shows is that for the first 1.5 million years of the Pleistocene, the ice ages were different. They were smaller, shallower, and, most importantly, faster. The ice sheets would grow, and then they would melt away, over and over, with a clear, predictable rhythm. But the rhythm was not 100,000 years. It was 41,000 years. The planet wasn't marching to the beat of its orbit's shape, eccentricity. It was marching to the beat of its tilt, obliquity. This was the dominant driving force. The 41,000-year cycle, which we'll explore in detail later, controls the severity of the seasons. And for 1.5 million years, this was the boss of the ice ages. The ice sheets grew, they hit a maximum, and then the 41,000-year tilt cycle would trigger a warmer summer, and they would melt away again. It was a clean, predictable clock. Then, about 1 million years ago, something breaks. The rhythm changes. This event is known as the mid-Pleistocene transition, and it is one of the greatest unsolved mysteries in paleoclimatology. Scholars still argue fiercely over what caused it. The 41,000-year clockwork, which had been running the show for over 1 million years, suddenly loses its grip. The rhythm stutters, slows down, and then re-establishes itself on a new, much longer beat. The 100,000-year cycle takes over, and this new cycle is not just longer, it's colder. The shallow ice ages of the 41,000-year world are gone. They are replaced by the brutal, deep freeze ice ages that we all think of. These new 100,000-year cycles see the ice sheets grow far larger, far thicker, and stay for much, much longer. The warm interglacial periods in between, like the one we're in now, become incredibly brief, just tiny warm blips in a new world defined by overwhelming cold. This is the great problem. We now have a planet that is locked into a 100,000-year pattern of freezing and thawing. But the astronomical cycle that matches this rhythm, the change in Earth's orbital shape, is the weakest of all the orbital cycles. It provides almost no change in the total sunlight the Earth receives. So, why? Why did the planet's pacemaker suddenly switch from a strong, clear, 41,000-year signal to a weak, feeble 100,000-year one? Why did the ice ages suddenly get so much worse? To answer that, we can't just look at the planet anymore. We have to look at the clock itself, and the brilliant, obsessed librarian who first figured out how to read it. So we have a new, deeper mystery. The planet's climate clock, which for 1.5 million years ran on a clean 41,000-year cycle, suddenly and mysteriously switched to a new, longer and colder 100,000-year rhythm. And this new rhythm is tied to the weakest of all the astronomical cycles. This is the 100,000-year problem, and it's a giant contradiction. To figure out what's going on, we have to wind back the clock. We need to leave the deep-sea cores and the geological surveys and travel to the early 20th century. We are not looking for a geologist. We are looking for a mathematician. His name is Milankovitch. He is a Serbian civil engineer and geophysicist, a man with a mind for numbers, not for rocks. And in the 1910s, while the rest of the world is descending into the chaos of war, Milankovitch is captured by a single, beautiful, almost romantic obsession. He believes the ice ages are not random, chaotic acts of God or geology. He believes they are a grand, cosmic clockwork, a predictable waltz danced by the Earth and the Sun. And he believes he can find the math that governs it. He doesn't travel to glaciers, He doesn't chip at rocks. He works from his desk, with piles of paper, a slide rule, and an incredible amount of patience. He is, for all intents and purposes, the first climate modeler. He builds his grand theory not from dirt, but from pure mathematics. He starts with the work of earlier astronomers who knew the Earth's orbit wasn't a perfect, stable circle. He knows it changes, but he is the first to meticulously, painstakingly calculate how 3 separate cycles all interact with each other. First is eccentricity, the 100,000-year cycle we've been talking about. This is the shape of Earth's orbit, which slowly stretches from being nearly a perfect circle to a slightly more flattened oval, or ellipse, and back again. This, as we've noted, is the weakest cycle. Second is obliquity, the 41,000-year cycle. This is the tilt of Earth's axis. It's the reason we have seasons. This cycle sees our tilt rock back and forth from about 22.1 degrees to 24.5 degrees. A greater tilt means more extreme seasons. Third is precession, a 26,000-year wobble, like a spinning top just before it falls over. This wobble determines when our seasons happen relative to our closest and farthest points from the sun. Milankovitch spends the next 30 years of his life hand-calculating how these 3 independent, messy cycles combine. He creates what is now his masterpiece, the insolation curve. It's a graph that shows the precise amount of Buller radiation, sunlight, that any given latitude on Earth, he chose the northern hemisphere, would receive over a period of thousands of years. But the math was only half his genius. His real insight was his theory. He proposed that the key to starting an ice age was not, as everyone assumed, an incredibly cold winter. A cold winter just makes a lot of snow. The real key, he argued, was a cool summer. His logic was simple and elegant. An ice age begins when the orbital cycles line up just right to create a series of mild, cool summers in the northern hemisphere. Why? Because a cool summer is not hot enough to melt the previous winter's snow. The snow stays. The next winter, more snow falls on top of it. The next cool summer, that snow also stays. The pile gets bigger. It compacts into ice. The patch of white grows. And as it grows, it triggers the albedo feedback loop we talked about. The white ice reflects sunlight, making the local area even colder, which attracts more snow, which reflects more sunlight. It's a runaway effect. Milankovitch had, on paper, discovered the trigger for the ice ages. He published his life's work in a massive volume in 1941, and the scientific community, for the most part, completely ignored him. Geologists who were just beginning to accept the then fringe theory of continental drift were not impressed. His calculations were too neat, too astronomical. They couldn't go out and find this 100,000-year cycle in the rocks. His work was seen as a brilliant mathematical curiosity, but not the answer. He died in 1958, his grand theory still waiting in the wings, unproven. Decades passed. Now, it's the 1970s. We have a powerful new scientific technology: deep ocean drilling. For the first time, scientists in the CliMap project can pull up long, continuous cores of sediment from the ocean floor, giving them an unbroken record of the past. By analyzing the oxygen isotopes in the tiny fossilized shells of plankton found in these cores, they can reconstruct past global temperatures. In 1976, 3 scientists, Hayes, Imbrie, and Shackleton, published a landmark paper. They took their new high-resolution climate record from the deep sea, and laid it next to Milankovitch's 50-year-old hand-calculated insolation curves. The match was perfect. The planet's climate was marching to the beat of his drum. The 100,000-year, 41,000-year, and 26,000-year signals were all there, clear as day, in the geologic record. The quiet librarian, the patient mathematician from Serbia, had been right all along. He had found the planet's pacemaker from his desk. But this grand vindication only made our mystery deeper, because the data also confirmed what he knew. The 100,000-year cycle was, astronomically, the weakest of all. Yet in the climate record of the last 1,000,000 years, it was the loudest one. The Earth was, for some reason, amplifying this one tiny whisper into a planet-shattering roar. This is it. This is the central nagging mystery of the modern Ice Age. Milankovitch was right. His math was perfect. The deep-sea cores proved it. But that proof just exposed a deeper paradox. The 100,000-year cycle, the one that defines the brutal, deep freeze world of the last 1,000,000 years, is the wrong one. Let's look at it again. This is the cycle of eccentricity. It's the slow 100,000-year pulse of Earth's orbit being pulled from a near-perfect circle to a slightly more flattened ellipse, mostly due to the gravitational tug of Jupiter and Saturn. But here's the problem. The change in total sunlight, insolation, this cycle produces is tiny. It's almost nothing. It's a whisper. Meanwhile, the 41,000-year obliquity cycle, the tilt of the axis, is a hammer blow. It dramatically changes the difference between summer and winter. It's a much, much stronger astronomical signal. And as we know, the planet used to march to this 41,000-year beat. So, this is the 100,000-year problem in a nutshell. Why, around 1,000,000 years ago, did the Earth stop listening to the loud 41,000-year signal and start, instead, building its entire climate rhythm around the faintest whisper it could hear? Milankovitch's basic theory was right. The orbits are the trigger. But his details were incomplete. He treated the Earth like a passive, simple billiard ball, just warming or cooling based on the sunlight that hit it. The answer is that the Earth is not a passive billiard ball. It's a complex, living system. It has its own internal machinery, its own rhythms. And that machinery is built on positive feedback loops. These loops don't create the climate change, but they amplify it, turning a tiny, insignificant nudge into a planet-altering shove. We've already met the first one. Albedo. Remember that continent-sized mirror on Antarctica? The same thing happens in the north. The Milankovitch cycle provides a few cool summers. A little bit of snow survives. That little white patch reflects sunlight, making the ground beneath it colder than the ground next to it. This makes it easier for more snow to stick around next year. That patch grows. It reflects more sunlight. It gets colder. This is the classic runaway effect. The ice sheet literally creates the cold it needs to grow bigger. But albedo alone isn't enough to explain the 100,000-year mystery. It's too fast. It can't explain why the ice ages got so long. For that, you need the second, more powerful feedback loop. You need the planet's own thermostat, the carbon cycle. This is the big one. We think of CO2 as a driver, which it is for us. But for the planet, it's also part of a feedback. And the key to it is the ocean. Here's a simple scientific fact. Cold water can absorb and hold more dissolved gas than warm water. You know this instinctively. A can of soda left open on a hot day goes flat in minutes. The CO2 bubbles right out. An ice-cold can stays fizzy for much longer. The ocean is just a very, very large can of soda. Now, let's put the whole process together. This is how you solve the 100,000-year problem. The weak orbital whisper provides a tiny nudge, a slightly cooler summer. This allows a little more ice to grow in the north. This tiny bit of ice, and the slightly cooler global temperatures it creates, starts to chill the world's oceans. The oceans, now a little colder, begin to absorb CO2 from the atmosphere. They pull the planet's greenhouse blanket off, bit by bit. This reduces the greenhouse effect, which cools the entire planet down, not just the patch of ice in the north. This global cooling allows the ice sheets to grow even bigger and faster. This larger ice sheet, the albedo effect, reflects even more sunlight, which cools the planet further. And this further cooling chills the oceans more, causing them to absorb even more CO2. And on it goes. The planet is now in a vicious cycle, a runaway feedback loop, dragging itself down into a deep freeze. The albedo and the carbon cycle are working together, amplifying that tiny orbital whisper into a deafening roar. This, scholars now argue, is the answer to the mid-Pleistocene transition. The planet's climate system, for some reason, perhaps a long-term slow cooling, tuned itself to this new frequency. The 100,000-year cycle became the perfect slow rhythm to entrain these massive, slow-moving feedbacks of ice growth and carbon absorption. The 41,000-year cycle was just too fast. By the time it could get a good feedback loop going, the cycle would reverse, and the ice would melt. The 100,000-year cycle was just slow enough to let the ice sheets grow to truly monstrous proportions, and to let the ocean suck down enough CO2 to lock the planet into a deep freeze for tens of thousands of years. It's not the force of the cycle that matters, it's the timing. It's the one rhythm that the Earth's own machinery could lock on to. So, we've solved the 100,000-year problem by realizing the Earth isn't a passive victim. It's an active amplifier, using its own carbon cycle and albedo to latch onto that 1 week slow beat. But in solving that, we've created a new question. What about the old boss? What about that 41,000-year cycle that ran the show perfectly well for the first 1.5 million years of the Ice Age? Let's dedicate this section to that original pacemaker. This is the cycle of obliquity, or, more simply, Earth's tilt. Right now, you're sitting on a planet that is tilted on its axis by 23.4 degrees relative to its orbit around the Sun. This tilt is the single most important reason for your existence. It's the reason you have seasons. When your hemisphere is tilted toward the Sun, it's summer. When it's tilted away, it's winter. But this tilt is not stable. It's not a fixed, constant 23.4 degrees. Under the gentle, persistent gravitational tug of the other planets, again, mostly Jupiter, the Earth rocks back and forth. It's a slow, steady, 41,000-year-long nod. At its minimum, the tilt is only 22.1 degrees. The Earth is standing up straighter. At its maximum, the tilt reaches 24.5 degrees. The Earth is leaning over more. This may not sound like a huge difference, just a couple of degrees, but the climatic consequences are enormous. Think about it. When the tilt is at its maximum, 24.5 degrees, the planet is leaning way over. This makes the seasons far more extreme. For the northern hemisphere, this means blazing hot summers, as it's tilted more directly at the sun, and frigid, dark winters, as it's tilted farther away. When the tilt is at its minimum, 22.1 degrees, the Earth is standing up straighter. The seasons become much, much milder. The summers are cooler, and the winters are warmer. Now remember Milankovitch's great insight. You don't start an ice age with a cold winter. You start it with a cool summer. So, this 41,000-year cycle is the perfect ice-on switch. Every time the Earth nods into a period of low tilt, 22.1 degrees, the Northern Hemisphere experiences a long stretch of mild, cool summers. These are the summers where the previous winter's snow doesn't melt. This is the trigger. The albedo feedback kicks in, and an ice age begins. And the scientific evidence from those deep-sea cores is undeniable. For the first 1.5 million years of the Pleistocene, this is exactly what happened. The planet's climate marched in lockstep with this 41,000-year nod. The ice sheets would grow, and then, as the tilt rocked back to its maximum, the scorching hot summers would return and melt them away again. It was a clean, reliable, one-on, one-off system. The quirky tidbit here is to imagine what life was like for our very early ancestors, like Homo erectus living under this rhythm. It was a faster world. The climate was still volatile, but the glacial and interglacial periods were shorter, each lasting only about 20,000 years. The changes were more rapid, the deep freezes less. Deep. It was a different kind of evolutionary pressure. So why did it stop? Why did this perfectly good, powerful, and effective pacemaker suddenly lose control around 1 million years ago during the mid-Pleistocene transition? Scholars still argue fiercely over this. There is no single consensus answer. It's the holy grail of paleoclimatology. But one of the most compelling ideas is that the system just broke. The running hypothesis is that the planet, over millions of years, was undergoing a very slow, very gradual background cooling. Perhaps the Himalayan uplift was still sucking CO2 out of the air, or some other long-term slow-burn process. The average temperature of the planet was slowly ticking downwards. For the first 1.5 million years, this wasn't a problem. The 41,000-year cycle's hot summers were still hot enough to overcome the background cooling and melt the ice sheets every time. But then, around 1 million years ago, a threshold was crossed. The background cooling got just a little too cold. The ice sheets during one of the glacial periods grew just a little too big. They became too thick, too massive, and too stable. The cycle rocked back. The 41,000-year clock said, "Okay, time for the hot summers. Melt!" And the ice sheets didn't. They had become so large that their own albedo, their own self-generated cold, was enough to survive the hot summers. They were stuck. The 41,000-year cycle, the old boss, was still shouting orders, but the ice sheets were now too big to listen. The planet was now locked in a deep freeze, stuck in a glacial period that the 41,000-year cycle could not break. The system was broken. It was only when the other cycles, the 100,000-year eccentricity and the 26,000-year precession, all lined up just right in a perfect super summer configuration, that the system finally had enough power to thaw the monstrous ice sheets out. And so, a new, slower, more brutal rhythm was born, one dictated by the 100,000-year cycle, because that was the only one slow and powerful enough to end the cold that the 41,000-year cycle could no longer control. We've now got the two main components of the Ice Age clock. We have the 41,000-year tilt, obliquity, which sets the baseline for the seasons, and we have the 100,000-year eccentricity, orbit shape, which acts as the slow master cycle that the Earth's own feedbacks have latched onto. But there is one final complicating movement. This is the 26,000-year cycle of precession, and it's the one that adds the last layer of complexity. If eccentricity is the shape of the orbit, and obliquity is the tilt of the axis, precession is the direction the axis is pointing. The easiest way to think about this is to imagine a spinning top. When you first spin it, it spins perfectly upright. But as it starts to slow down, it begins to wobble in a slow circle. The Earth's axis does the exact same thing. This 26,000-year wobble means that the North Star isn't a permanent fixture. Today, our North Pole points at Polaris. But 13,000 years ago, it pointed at a different star, Vega. In another 13,000 years, it will point back to Vega again. This wobble seems like an abstract, fringe tidbit for astronomers, but its climatic effect is profound. It's the tiebreaker of the seasons. Here's why. Remember that the Earth's orbit is not a perfect circle. It's a slight ellipse, thanks to the 100,000-year eccentricity cycle. This means there is a point in our orbit when we are closest to the Sun, perihelion, and a point when we are farthest from the Sun, aphelion. Precession determines which season you are in when these two events happen. Let's look at the situation right now, in our modern world. The Northern Hemisphere experiences winter when the Earth is closest to the Sun, perihelion, in early January. The Northern Hemisphere experiences summer when the Earth is farthest from the Sun, aphelion, in early July. Think about what this means. Our winters are made milder because we're getting more solar energy by being closer to the Sun, and our summers are made cooler because we're farther away. The precession cycle is currently giving the Northern Hemisphere, where the great ice sheets grow, a very mild, low-contrast set of seasons. But now, wobble the axis. Let's go back 13,000 years, half a cycle. The situation was completely reversed. The Northern Hemisphere had summer when the Earth was closest to the Sun, and winter when it was farthest away. The result? Scorching, super-hot summers, getting maximum sun at the closest point, and brutally cold, dark winters, getting minimum sun at the farthest point. The seasons become incredibly extreme. This cycle is the volume knob for seasonal contrast, and this is the key to understanding one of the most dramatic climate events of the recent past, the Green Sahara. For thousands of years during the early Holocene, our current warm period, the Sahara Desert wasn't a desert. It was green. The scientific evidence is overwhelming. Rock paintings from the middle of the desert show people hunting giraffes, elephants, and hippos. Sediment cores from the Atlantic show that the dust blowing off Africa stopped. Pollen records show that savanna grasses and even trees grew where there is only sand today. What caused this African humid period? It was precession. During that time, the 26,000-year wobble meant that Northern Hemisphere summers were at their closest point to the Sun. These super-hot summers over North Africa created an incredibly strong, reliable African monsoon. The intense heat over the land created a low-pressure zone that for thousands of years sucked massive amounts of moisture from the Atlantic deep into the continent. It rained year after year, turning the world's largest desert into a vast, livable savanna. Then, as the wobble continued, the volume knob was turned down. The Northern Hemisphere's summer slowly moved to its farthest point from the Sun, where it is today. The summers cooled, the monsoon weakened, and the Green Sahara collapsed back into desert, forcing its human populations to migrate. Many of them historians argue, to the only remaining water source, the Nile Valley, kick-starting Egyptian civilization. So now, we have the complete clockwork. This is how the three Milankovitch cycles dance together. 1. Eccentricity, 100,000 years, sets the stage. It determines the shape of the orbit, whether it's a mild circle or an extreme ellipse. 2. Obliquity. 41,000 years arranges the scenery. It sets the tilt of the axis, how extreme the seasons are at a baseline. 3. Precession, 26,000 years, sets the timing. It determines when the seasons happen, whether your super summers or mild summers line up with your closest or farthest point from the sun. Together, these three interlocking cycles are the insulation curve. They are the pacemaker. They are the external trigger that the Earth's own internal feedbacks, albedo and CO2, listen to, creating the 100,000-year pulse that has defined our world. And now that we understand the machine, it's time to see what that machine built. It's time to visit the world it created, the glacial world. We've built the clockwork. We've seen the gears, eccentricity, obliquity, precession. We've seen how the Earth's own machinery, the albedo and carbon cycles, amplifies the faint ticks of that clock into a planet-shattering roar. Now it's time to see the result. It's time to step out of the abstract and into the world that this machine built. You're traveling to 20,000 years ago. This is the last glacial maximum, or LGM. This is the name for the absolute rock-bottom coldest point of the last 100,000-year cycle. This is the world that Homo Sapiens and Neanderthals had to survive. This is the world of the great megafauna, and it is, by every measure, an alien planet. The first thing you notice isn't the cold, it's the ice. It's not just at the poles, it's on the continents. You're hovering over North America, you're looking for New York, or Chicago, or Toronto. They are not there. They are buried. You are looking at the Laurentide ice sheet, and the word sheet is a terrible, misleading name. It's not a flat sheet. It is a dome. It is a continent-sized mountain of solid ice, a single, continuous, crushing mass. Its center and its thickest point is not the North Pole. It's right over Hudson Bay. Here, the ice is estimated to be over 3 kilometers, almost 2 miles, thick. Think about that. A mountain of ice stacked 3,000 meters high, just sitting on the continent. From this central dome, the ice flows outward under its own incredible weight, like infinitely slow honey, covering all of Canada and scraping deep into the northern United States. The farthest advance of this ice is what carved out Long Island, what dumped the boulders you see in Central Park, and what defines the entire geography of the Great Lakes. This is not a static object. It is a geological force. The sheer weight of this ice is beyond comprehension. The scientific evidence for this is not on the surface, but in the rock below. The ice is so heavy that it is pressing the entire continent's crust down into the hot, flexible mantle beneath it. This is a process called isostatic depression. Right now, as you stand in the LGM, the land under Hudson Bay has been pushed down by almost 300 meters. The land is sinking, sagging under the unbelievable burden. A quirky tidbit. Today, 20,000 years later, that same land is still slowly rising, or rebounding, from this pressure, like a foam mattress slowly regaining its shape. And North America isn't special. You cross the Atlantic. Europe is in the same state. You're looking at the Fennoscandian ice sheet. It's another massive dome, centered on Scandinavia, covering all of Norway, Sweden, Finland, and burying the British Isles. The ice flows south, covering northern Germany, Poland, and scraping its way across Russia. The world is white. The northern hemisphere is a fortress of ice. But then you notice something strange. You go farther north, to the places you expect to be the most glaciated. You go to central Alaska. You cross the Bering Strait into Siberia, and you find no ice sheets. This is one of the great quirky tidbits of the Ice Age. These places, while brutally, painfully cold, are ice-free. Why? Because an ice sheet needs one thing even more than it needs cold. It needs snow. It needs moisture. And these places are a polar desert. They are so far inland, and the global climate is so dry that no moisture ever reaches them. It's simply too cold to snow. So instead of a white, glaciated world, you find a brown, frozen, barren one. This is the vast, ice-free plain that will, as we'll see, become a highway for animals and humans. Now you pull back. You look at the whole planet. The climate is not just cold. It is dry. It is the driest the planet has been in millions of years. The reason is simple. All the water is gone. It's not in the oceans. It's not in the atmosphere as clouds. It's been stolen, hoarded, and locked up in those two colossal ice domes, the Laurentide and the Fennoscandian. They are giant, frozen reservoirs of the world's fresh water. The result is that the rest of the planet is arid. The Amazon rainforest is not a rainforest. It's a dry savanna with patches of trees. Africa is drier. The world's deserts are larger and more aggressive. And because it's dry and cold, it is also windy. The huge temperature difference between the massive, high-pressure, cold domes of the ice sheets and the rest of the planet creates ferocious, non-stop winds. And these winds have nothing to pick up but dust. The world of the LGM is a world of perpetual, planet-scale dust storms. The air is thick with it. This isn't just a guess. The scientific evidence is in ice cores from Greenland, where distinct, thick layers of dust mark the LGM. It's in massive deposits, hundreds of feet thick, across China and the central United States, called loess. This is all just wind-blown, glacial dust, silt that was ground up by the ice sheets, dried out, and then blasted across the continents for thousands of years. This is the air you have to breathe. This is the glacial world. It's a world of bright, reflective, blinding ice. It's a world of crushing weight. And it's a world of brown, dry, endless, choking dust. You're standing in this brutal, frozen, dusty world of the last glacial maximum. And you notice something else. You look at the coastlines. You look at where the land meets the sea, and the map of the world is wrong. Where did all that water go? All the moisture that was sucked out of the air and the oceans to build those 3-kilometer-high domes of ice. It had to come from somewhere. It came from the oceans. This is the most profound geographical change of the LGM. The ice sheets are hoarding so much of the planet's water that global sea levels have fallen by 120 meters. That's 400 feet. Take a moment to process what that means. It doesn't just mean the beaches are wider. It means that entire continents have changed shape. This 120-meter drop isn't a minor detail. It is the single most important scientific evidence for the scale of the ice sheets, and it's the key to understanding all of human and animal migration in this period. You're standing on the coast of England. You look east towards Europe. There is no English Channel. It's gone. You are looking at a vast, rolling plain of cold, grassy tundra, veined with rivers. This is Doggerland. You can pick up your spear, and you can walk from what is now London to what is now Amsterdam. This isn't a hypothetical. This is a lost world. Today, fishing trawlers in the North Sea regularly dredge up the scientific proof. Mammoth bones, reindeer antlers, and even the exquisitely carved bone and stone tools of the humans who hunted them on this vanished plain. Now you go north, to the top of the world. You're standing between Siberia and Alaska. The Bering Strait, that narrow, icy waterway that separates Asia from the Americas, is also gone. It's not a strait. It's not even a bridge, as it's so often called. That word is too small. You are standing on Beringia. It is a continent-sized landmass, a vast, treeless, ice-free plain that connects two worlds. At its widest, it's over 1,500 kilometers, 1,000 miles across. This is the quirky tidbit that rewrites the map. Beringia wasn't just a highway people ran across. It was a destination. It was an enormous, habitable, resource-rich region in its own right, what scholars call the Beringian standstill hypothesis. People and animals lived here for thousands of years, trapped between the ice sheets of America and the glaciers of Siberia, before they ever set foot in what is now Alaska. You fly south to the other side of the world, where there are no ice sheets. The 120-meter drop is global. It affects the warm parts of the world just as much. You look at Southeast Asia. The map is completely unrecognizable. The Philippines, the islands of Indonesia, like Sumatra, Java, and Borneo, and the Malaysian peninsula are all one continuous landmass. This is the lost continent of Sunda. The modern-day islands are just the mountain peaks and highlands of this submerged world. A short hop to the south, you see another one. Australia and New Guinea are not separate. They are fused into a single giant continent called Sahul. This redrawn map is the story of humanity. The fringe idea that Aboriginal Australians have oral history stories of a flooding is a powerful link to this past. This map is how people got to Australia 65,000 years ago, island hopping across a chain of islands that were much, much closer together. It's how humans, following the herds of mammoths, eventually walked from Siberia to Alaska. The entire world is connected in new ways. The Persian Gulf? It's not a gulf. It's a dry river valley, with the Tigris and Euphrates rivers flowing all the way down to the Strait of Hormuz. Florida is twice as wide as it is today. You could walk from mainland Asia all the way to Japan. This is the world of the LGM. It's a world where the coastlines you know are a lie, and the true map of the human past is now 120 meters underwater. You're standing on this new, expanded land. You've walked across Doggerland, or perhaps you're on the vast, dry plain of Beringia. You are not on the ice. You're in the ice-free zone, right next to the towering, kilometers-high wall of the Laurentide Sheet. Your modern brain has a clear expectation for what this place should look like. An ice age next to a glacier must mean tundra. You're picturing a barren, waterlogged landscape, a soggy, acidic, moss-covered bog, like modern-day northern Siberia or Canada. A place that is bleak, miserable, and frankly, not very nutritious. You might see a few reindeer, maybe a muskox. You certainly wouldn't expect to see an elephant. But you look around, and the world you see is wrong. It's not a wet, mossy bog. It's not a forest. It's something else entirely. You are standing on an ecosystem that no longer exists on Earth. This is the single biggest quirky tidbit of the LGM. The dominant environment of the Ice Age has no modern analogue. Scientists call it the Mammoth Steppe, and it is vast. This single, unbroken biome stretches from the western coast of France, across all of northern Europe and Asia, over the Beringia land bridge, which is just more steppe, and deep into Alaska and Canada's Yukon territory. It is the largest, most continuous ecosystem on the planet. And it is not empty. It is teeming with life. You are looking at the Serengeti of the Ice Age. The ground is thundering with herds, not just mammoths, but thousands of wild horses, bison, woolly rhinos, and reindeer. And stalking them, you see the predators, packs of dire wolves, cave lions, and the saber-toothed cats. This leads to the single greatest question of the LGM, what scientists call the productivity paradox. Scholars still argue over this. How could this cold, barren-looking landscape possibly support so many enormous animals? A modern tundra can't feed a single elephant, let alone millions of them for thousands of years. What was the secret? The answer is that the Mammoth Steppe had a few secret ingredients that are now gone. First, it was dry. Remember those global, non-stop winds? The LGM world was incredibly arid. Unlike modern tundra, where the permafrost melts at the top and creates a soggy, impassable bog, this land was bone dry. The soil was firm, not waterlogged. In the brief, intense, 24-hour sunlight of the Arctic summer, the sun could actually bake this dry soil, unlocking nutrients. Second, it was fertilized. Continuously. Remember the endless dust storms? That lease that choked the air? That wasn't just dust. That was the scientific evidence for the steppe's success. It was pulverized rock, freshly ground up by the glaciers and delivered by the wind, for free, all over the world. This was a non-stop, natural delivery of mineral-rich fertilizer, resupplying the soil every single year. And then there was the other fertilizer, the animals themselves. The millions of mammoths, horses, and bison were not just taking from the land. They were giving right back. They were part of a massive, walking, manure-spreading system. This constant recycling of nutrients, combined with the fresh mineral dust, made the soil incredibly rich. And because of that, the vegetation was completely different. The pollen we find in frozen soil cores isn't just moss. It's a rich, diverse, magic carpet of food. It was, yes, a lot of highly nutritious grass, but it was also packed with forbs. Forbs is just the scientific term for the leafy, non-grassy flowering plants. Imagine fields of Arctic poppies, nutrient-dense sagebrush, and protein-packed herbs. This combination of grass and forbs was the perfect megafauna superfood. It was high-calorie, high-protein, and it grew incredibly fast. The giants would move through, eat the nutritious plants, trample the ground, which, as a bonus, kept any new trees from growing, and re-fertilize the area, which would then spring back to life. This was the engine of the Ice Age, a lost, self-reinforcing continental-scale food machine that was part grass, part flower, part dust, and let's be honest, a very large part manure. And it's this magic carpet of food that made the titans of the ice possible. We've spent all this time in the Northern Hemisphere, watching the ice domes grow and the Mammoth Steppe thrive. It's easy to forget, but the Earth has two poles. So what was happening at the bottom of the world during all this LGM drama? What was going on in Antarctica? You travel south, past the equator, looking for the same kind of catastrophic change, and you find nothing. Antarctica, during the last glacial maximum, looked almost exactly like it does today. It was simply already frozen solid. While the North was in this chaotic, dynamic cycle of growing and melting, Antarctica was the control group. It's the sleeping giant we met back in Section 3, and it has not woken up. It was, and is, the great anchor of the planet's climate. Its role in the LGM wasn't to change, but to stay the same. Its massive, continent-sized, permanent white surface is the single biggest albedo reflector on the planet. It's the foundation of the entire icehouse state. It's the permanent coolant system, the vast white mirror that's always bouncing sunlight back into space, keeping the planet's average temperature low enough for the northern ice sheets to even form in the first place. This is the key difference. The northern hemisphere ice sheets, the Laurentide, the Fennoscandian, are dynamic. They are temporary. They come and they go with the 100,000-year pulse. Antarctica's ice sheet, at least the East Antarctic sheet, is ancient. It's been there for 34 million years. It is the boss of the Ice Age, the stable, cold heart of the entire system. However, that's not the whole story. And this is where we find the new science that has become critical to our modern world. The Antarctic ice sheet is not one single stable block. It's two. There is the East Antarctic ice sheet, the big one, which is a high, dry, stable dome of ice resting on a solid, continental landmass high above sea level. It's the sleeping giant. But then there is the West Antarctic ice sheet, WAIS. And this is the quirky tidbit with a terrifying implication. The WAIS is fundamentally unstable. Why? Because it is a marine-based ice sheet. Most of its ice is not sitting on land above sea level. It's sitting on bedrock that is hundreds or even thousands of meters below sea level. This makes it incredibly vulnerable. A land-based glacier, like in the East, only melts from the top down, from the air. A marine-based glacier can be melted from the bottom up. All it takes is a current of slightly warmer ocean water to get underneath it, eating it away from its foundations, out of sight. This instability is the single biggest open scholarly debate in modern glaciology, and it's our direct, frightening link to the LGM's past. We are watching this exact process happen today. The lessons we are learning from the WAIS's vulnerability are the key to understanding our own future. So while the rest of the LGM world was a Northern Hemisphere story, its silent partner was always Antarctica. And what about the rest of the Southern Hemisphere? It was certainly colder. Glaciers grew in the Andes in South America and in the Southern Alps of New Zealand, but nothing on the continental world-changing scale of the North. The LGMs are, their heart, a northern story. But it's a story that can only happen because the great, sleeping southern anchor holds the entire planet in the cold. And with that system in place, it's time to meet the incredible creatures this world produced. It's time to meet the Titans. You're standing on the Mammoth Steppe. It's time to meet the star of the show, the poster child of the Ice Age, an animal so iconic it gives the entire ecosystem its name. You hear a low, rumbling sound. The frozen ground is vibrating. And then you see it. A herd of Mammuthus primigenius, the woolly mammoth, moves across the plain. The first thing you notice is they're not quite the towering, skyscraper-sized monsters you imagined from cartoons. That's a common misconception. A fully grown male woolly mammoth was about the size of a modern African elephant, maybe a bit shorter and stockier. The real giants, like the steppe mammoth or the Columbian mammoth of North America, were much larger. But this, the classic woolly one, was a more compact model. And it had to be. It was an adaptation. It is, from head to toe, a masterpiece of cold weather engineering. You start with the most obvious feature, the fur. This isn't just a coat, it's a two-part system. On the outside, you have the guard hairs, long, shaggy, coarse strands up to a meter, 3 feet. Long, that act as a windproof, waterproof shell. They're often caked in mud, snow, and their own oil. Beneath that, pressed against the skin, is a dense, fine, woolly undercoat, like a layer of cashmere that traps body heat. And under that is a thick, 10-centimeter, 4-inch layer of solid body fat, the final layer of insulation. You look at its head. The ears are tiny. This is a crucial mainstream historical fact of biology known as Allen's rule. Animals in cold climates evolved to have smaller extremities, ears, tails, limbs, to reduce the amount of skin surface area exposed to the cold, preventing heat loss. A woolly mammoth's ear is less than a sixth the size of an African elephant's, which uses its giant, flapping ears as radiators to dump heat. This animal has the opposite problem. Its whole skull is a piece of bioengineering. It has a high, domed head, but this isn't to hold a giant brain. The inside of that dome is honeycombed with massive sinus cavities. This is the mammoth's internal furnace. As it inhales the minus 30 degrees Celsius air, the air swirls through these warm, mucus-lined sinuses, being preheated before it ever hits the lungs. It's a heat exchanger built into its own face. The mouth is a grinding machine. You watch one rip up a clump of the dry, tough steppe grass. It's not dainty. The animal is designed to process thousands of pounds of this abrasive, silica-rich superfood we talked about. Its teeth aren't individual molars like ours. They are massive, brick-like grinding plates that are pushed forward from the back of the jaw as the old ones wear down, like a conveyor belt. A mammoth would go through 6 full sets of these teeth in its 60 to 70-year lifetime. When the last set wore out, it could no longer eat, and it would starve. Then there are the tusks. They are enormous, curving spirals of ivory that can grow up to 15 feet long. They are not just for show. You watch a female use hers with incredible dexterity. She's sweeping them in a wide arc, sweeping the snow off the ground to get to the buried grass beneath. She's using them as a snowplow. You see a young male use his to break the bark off a willow shrub. They were tools. They were also, without a doubt, weapons for fighting off predators, and in males, a costly signal of status, like a peacock's tail. But the most incredible, quirky tidbit of all is the one you can't see. It's hidden in their blood. This is the cutting-edge scientific evidence gleaned from the DNA of exquisitely preserved frozen mammoths. Scientists found that mammoths had a mutated gene for hemoglobin, the protein in red blood cells that carries oxygen. Here's why. Your hemoglobin doesn't work well when it's cold. If your hands or feet get too cold, they go numb, in part because your blood is too chilled to release its oxygen to the tissues. The mammoth's mutated hemoglobin was indifferent to the cold. It could release oxygen to its cells at 0 degrees Celsius, 32 degrees Fahrenheit, just as easily as at 37 degrees Celsius, 98.6 degrees Fahrenheit. Their blood was, quite literally, anti-freeze. You watch the herd. The social structure is obvious. It's a matriarchal society, just like modern elephants. A wise, old female leads a group of her sisters, daughters, and their young calves. The adult males are solitary, wandering the steppe alone, only joining the herds to mate. We know all this because of the frozen finds. In 2007, a reindeer herder in Siberia discovered Lyuba, a 1-month-old baby mammoth who died 42,000 years ago. She is perfect. Her skin, her eyelashes, her tiny trunk, all intact. In her stomach, we found not just her mother's milk, but the last meal of the herd she was with. Trace amounts of steppe grass, herbs, and most poignantly, the pollen of tundra flowers. Through her, we get a perfect, tragic snapshot of the world they called home. The mammoth is the icon of the Eurasian steppe, but the Ice Age was a global phenomenon. And because of that 120-meter sea level drop, the land bridge of Beringia connected that world to an entirely new one, the Americas. And if you think the mammoths were strange, the American megafauna were in a league of their own. This was a land of giants that had evolved in relative isolation for millions of years, and the results were truly bizarre. You travel south from the frozen plains of Beringia, down into what is now the southern United States or South America. The air is warmer. The environment is a patchwork of savanna, grassland, and open woodland. And the creatures here are from a different, older, weirder playbook. You see a small forest of trees, and one of them appears to be moving. Then you realize it's not a tree. It's an animal, rearing up on its hind legs to a height of over 4 meters, 13 feet. This is Megatherium, the giant ground sloth. Let's just get the scale right. When you hear sloth, you picture the small, slow, mossy creature hanging from a tree in the Amazon. This is not that. This animal is the size of a modern elephant. It weighs 4 tons. It is, by every definition, a giant. It's built like a tank, with a massive, wide pelvis and a thick, powerful tail. You watch it rear up, balancing on that tail and its colossal hind legs, and it uses its other weapon, its claws. They are enormous, sickle-shaped, talc-like appendages, not for killing, but for pulling. It hooks a giant branch and, with the casual immense power of a hydraulic machine, it pulls the entire tree down to its level to leisurely strip the leaves. Its biology is a marvel. It has no front teeth. It just has a muscular, prehensile tongue for grabbing leaves. Its thick hide is filled with osteoderms, small, pebble-like pieces of bone, like a natural suit of chainmail hidden just under the skin, making it incredibly tough to bite. But as strange as this animal is, its most baffling feature is the scientific evidence it left underground. In South America, particularly in Brazil and Argentina, paleontologists have been discovering something incredible: paleoburrows. These are not just holes, these are tunnels. Massive, sprawling underground tunnel systems, some over 2 meters, 6.5 feet high and wide enough to drive a small car into, that run for hundreds of feet. For decades, their origin was a mystery. But then, scientists found the smoking gun. Massive, fossilized claw marks raked into the walls and ceilings of these tunnels. A perfect one-to-one match for the giant claws of a ground sloth. This is the quirky tidbit that rewrites the book on these animals. They were diggers. They were excavating tunnel networks on a scale that no modern animal, not even a badger can come close to. The question is why? And on this, scholars still argue. What was the purpose of this colossal effort? Was it for shelter from the elements? Perhaps the temperature swings of the Ice Age? Were they giant birthing dens? A safe, protected place to raise their young? Or were they just trying to get away from the other, even more terrifying predators of the Ice Age? We simply don't know. But the image of a 4-ton, elephant-sized sloth, patiently, methodically, and obsessively digging a subway system is one of the most wonderfully strange and truly human, in its sheer absurdity, pictures the Ice Age has to offer. And as if that's not enough, you look past the sloth, and you see something else. It looks like a Volkswagen Beetle, painted in the camouflage of a tortoise shell. But it's moving, and it's not a car. This is Glyptodon. It is essentially a car-sized 2,000-pound armadillo. It is the armored tank of the Pliocene and Pleistocene. Its defense is one of the most perfect in the history of life. It's not a collection of small plates, like a modern armadillo. Its body is covered by a single, solid, fused dome of bone, an impenetrable 1-inch thick shell. It's a walking fortress. Even its head has a thick, bony cap for protection. It's a grazer. You watch it move, slowly, almost comically, through the grasslands, its head down, just mowing the grass. It's almost invincible. A predator like a saber-toothed cat can't get its claws or teeth through that shell. It can't get under it. The only tiny, vulnerable part is its underbelly. But if a predator gets too close, the Glyptodon just sits down. It hunkers down, pulling its legs in, and it becomes, for all intents and purposes, a solid, immovable, 2,000-pound rock of bone. And some of its relatives, like Doedicurus, evolved an even more spectacular piece of hardware. They had a massive, heavy, bony tail, and on the end of it, a devastating, spiked, mace-like club. It's a medieval weapon, a morning star, evolved by a giant armadillo. This presumably was used for fighting rival males, or for delivering a bone-shattering final word to any predator stupid enough to get too close. This is the American fauna, a world of elephant-sized, chain-mailed, tunnel-digging sloths and armored, mace-wielding, car-sized armadillos. And we haven't even gotten to the predators. You can't have a world filled with giant walking meals, mammoths, sloths, glyptodons, without an equally impressive and specialized cast of predators to hunt them. The Mammoth Steppe and the American savannas were a brutal arms race, and the carnivores that evolved here were some of the most formidable in Earth's history. Let's start with the most famous and the most misunderstood, Smilodon fatalis, the saber-toothed cat. The first thing you have to do is erase the image of a saber-toothed tiger. It was not a tiger. It wasn't even closely related. And it absolutely did not hunt like one. A tiger is a sleek, fast pursuit and pounce predator. Smilodon was a linebacker. It was built like a bear. It had immensely powerful, thick forelimbs, a muscular neck, and a short, bobbed tail. This was not a runner. This was a short-range ambush wrestler. And then, the fangs. Those iconic 7-inch kiabas are the key to its whole life. But here's the quirky tidbit you wouldn't expect. They were incredibly brittle. They were long and flat, like blades, but they were not strong. They would have snapped instantly if they hit bone. This immediately tells us how it didn't hunt. It wasn't leaping onto a mammoth's back and biting its spine. It wasn't clinging to a struggling glyptodon. So, how did it kill? The running theory is a two-step process. First, it used its immense upper body strength. It would burst from ambush, grab its prey, a bison, a young mammoth, a horse, and use its 1,000 pounds of muscle to wrestle the victim to the ground, pinning it completely. Only then, when the animal was immobilized, would it deliver the killing bite. It would open its jaw to a specialized 120-degree gape, something no modern cat can do, and use those sabers, not for crushing, but as a can opener. It would deliver a precise, puncturing bite to the soft, unprotected throat, severing the windpipe and carotid arteries. The prey would bleed out in seconds. It was a kill of brutal, efficient hydraulic strength, followed by surgical precision. But here is the most fascinating scientific evidence we have, and it comes from the La Brea tar pits in Los Angeles. Thousands of Smilodon are preserved there, and many of their skeletons show evidence of horrific, healed injuries. We see crushed limbs, broken ribs, and dislocated hips that had fully healed over months or years. An animal with a broken leg cannot hunt. In a solitary species, that is a death sentence. The clear implication is that Smilodon was social. It lived in prides, much like lions. This is the only way these wounded animals could have survived. Their group was bringing them food, protecting them, and caring for them. It's a profound, almost gentle image of these terrifying-looking cats cooperating to take care of their injured family members. Alongside Smilodon, you'd find its main competitor, the dire wolf. This animal, made famous by Game of Thrones, was very real. It was not a mythical, oversized fantasy beast. It looked, for the most part, like a modern grey wolf. Just more. It was about 25% heavier, built more like a brawler than a runner. It had a larger head, a thicker neck, and a much more powerful bite. Its teeth tell the whole story. A dire wolf's teeth were specialized for bone crushing, much like a modern hyena's. This was the cleanup crew of the Ice Age. They were pack-hunting specialists, but where a grey wolf pack might pick a carcass clean, a dire wolf pack would demolish it, cracking open the massive femurs of bison and horses to get at the marrow. They were the dominant, bone-shattering force of the American plains. And then, there was the one predator that scared everything. You're in a clearing. A Smilodon pack has just brought down a bison. They are feeding. Suddenly, the pack scatters, abandoning their hard-won meal. A new shadow falls over the kill. You look up and up. This is Arctodus simus, the giant, short-faced bear. This is not a large animal. This is a monster. Standing on its hind legs, it would be 3.5 to 4 meters, 11 to 13 feet, tall. It could look a basketball hoop in the eye. Weighing over a ton, it was the largest mammalian land predator of the Ice Age. And this is where we find our great open scholarly debate. What exactly did this giant do? For decades, scientists have argued over its lifestyle. One school of thought says it was a hyper-carnivore, a super predator. It had long, strangely slender legs for a bear. Maybe it was a runner? Could it, in a terrifying, loping gait, run down Ice Age horses? The other school of thought, and the one that's gaining more traction, is that it was the ultimate king scavenger. This is the Woolly Hypothesis. Why hunt when you are that big? Its long legs weren't for running down prey. They were for covering distance. It was a power walker, able to cover 100 miles in a day, moving across its vast territory. Its high-up head would let it spot kills from miles away, or smell them on the wind. it would just walk up, and everything, dire wolves, smilodon, even early humans, would simply get out of the way. It was a 1-ton kleptoparasite, the undisputed king of the Ice Age kill. The Mammoth Steppe was a grand theater, and while the mammoths, sloths, and great cats were the star performers, the stage was filled with a rich supporting cast. These were the other giants, the ones that truly defined the texture of this lost world. You're traveling across the frozen plains of what is now northern Europe or Siberia. You see a familiar shape, but one that seems completely out of place, like a refugee from the African savanna. It's a rhinoceros. This is Coelodonta antiquitatis, the woolly rhinoceros. It's a European and Asian giant, a perfect companion to the mammoth, and just as magnificently adapted. It's covered in the same thick, shaggy 2-layer coat of reddish-brown fur. It has the same small ears, the same short, stocky legs to conserve heat, and the same massive, grazing, focused body. But its most striking feature is its horns. It had 2, but the front one, the mainstream historical fact of the animal, was enormous. Unlike the conical, dagger-like horn of a modern rhino, the woolly rhino's was a bizarre, compressed blade of keratin. It was flattened from side to side, like a giant, dull saber, and it was keeled with a sharp front edge. For a long time, its purpose was debated. But scholars now argue that its use was identical to the mammoth's tusks. It was a snowplow. You watch it work. It sweeps its massive head from side to side, using that keeled horn to cut through the wind-packed snow and ice, scraping it away to get at the nutritious dry grasses buried beneath. We know this with certainty because, like the mammoths, we have found perfectly preserved specimens. In the Siberian permafrost, we've found frozen, intact rhinos. We have Sasha, an incredibly rare baby woolly rhino, who tells us what their young looked like. We have found adults with their fur, their skin, and even their last meals still preserved in their stomachs. This scientific evidence is undeniable. They were pure grazers, their digestive tracts stuffed with the grasses, and forbs of the Mammoth Steppe. They were, in every sense, the cold-weather cows of the Ice Age, a robust, tough, and supremely successful animal. You leave the rhino to its grazing and move to a patch of steppe near a river where a few willow shrubs are growing, and you see a creature that seems to defy physics. This is Megaloceros giganteus, the Irish elk. Let's clear up the quirky tidbits first. It was not an elk. It was a true deer, more closely related to a modern fallow deer. And it was not just Irish. We call it that because some of the most spectacular, well-preserved skeletons have been pulled from the bogs of Ireland. But this was a Eurasian animal, found from Ireland all the way to China. And it is, without a doubt, the most spectacular deer that has ever lived. The male, or stag, was a huge animal, over 2 meters, 6.5 feet, tall at the shoulder. But its body was just the stand for its masterpiece. The antlers. They are the largest antlers of any deer, ever, in the history of the planet. They are a solid wall of bone, spanning up to 3.6 meters, 12 feet, from tip to tip. They weighed 40 kilograms, 90 pounds. This is a biological absurdity. This is a costly signal of fitness pushed to its absolute evolutionary limit. To grow that much bone every single year, they shed and regrew them annually, like all deer. A stag had to consume an insane amount of calcium and phosphate. It had to be the healthiest, strongest, and best-fed male. It was a walking billboard that shouted to all females, "Look at me. I am so healthy, I have so many resources, that I can afford to grow this useless giant chandelier on my head. And that leads to the great open scholarly debate about its extinction. For a long time, the classic theory was that these antlers were its downfall. They were maladaptive. When the climate changed at the end of the Ice Age, and the open Mammoth Steppe was replaced by dense incoming forests, the stags simply got stuck. They couldn't navigate the trees and were easily picked off by predators. It's a poetic, tragic image, and it's probably partly true. But the modern answer is, as always, more complex. The real killer was likely the changing vegetation. The new post-Ice Age plants were not as rich in the minerals they needed to grow those antlers. The population's health failed. The costly signal became a fatal expense. But here, in the LGM, you just watch it. A full herd, the stags moving with a strange, proud, burdened grace, carrying a crown of bone that defines the sheer, glorious and bizarre extravagance of the Ice Age world. And in the shadow of these giants, another creature is making its way, one that is physically weak, poorly insulated, and seemingly completely unfit for this world. But it's the one that will outlast them all. It's time to meet the humans. You're watching these titans, the mammoths, the rhinos, the giant deer, navigate a world of impossible cold. And now you see another figure, huddled against the wind in a scraped-out hollow at the base of a cliff, tending a small, smoky fire. This is a human, but it's not one of your direct ancestors. This is a Neanderthal. For the last 100,000 years, they have been the true people of the Ice Age. They didn't arrive in the cold. They evolved in it. They are the original cold-adapted Europeans. And the first thing you must do is erase the club-dragging brute from your mind. This is a Victorian-era caricature, a prejudice born from the first arthritic and damaged skeletons we ever found. The being you're looking at is not a caveman. He is a sophisticated, intelligent, and profoundly human survivor. His body is a testament to cold-weather evolution. This is a mainstream historical fact of biology called Bergmann's rule. In a cold climate, bodies get wider and stockier. He is shorter than you, but immensely powerful. His chest is a massive barrel shape, and his limbs are short and thick. This low surface area to volume ratio is all about one thing, conserving heat. A tall, lanky, tropical body, like that of our ancestors, is a radiator, built to shed heat. His body is a furnace, a compact, dense shape designed to hold on to every precious calorie of warmth. Then you see his face. It's dominated by a massive, projecting nose. For decades, this was seen as a primitive feature. But scholars now argue it was the exact opposite. It was a highly advanced piece of adaptation. That fringe tidbit of a nose was his built-in heat exchanger, just like the one in the mammoth's skull. It was a complex radiator, filled with blood vessels and mucous membranes. When he inhaled the -30 degrees Celsius air, it swirled through this large nasal chamber, getting warmed and humidified before it hit his delicate lungs. When he exhaled, the heat and moisture were recaptured by the same system, conserving both. His face was, quite literally, air conditioning for the Ice Age. You watch him work. His hands are calloused and scarred, but his movements are precise. He is not tinkering. He is a master craftsman. He's using a technique we call Mysterian, and it's a world beyond simple rock bashing. He holds a carefully selected piece of flint, a prepared core. He's been working this core for hours, shaping it, visualizing the tool inside it. This is the Levallois technique. With a few precise strikes, he detaches a perfect, pre-shaped, razor-sharp flake. It's a point-of-sale tool. A knife, a scraper, a spear point, all in one. This is not brute force. This is abstract thought, foresight, and generations of passed-down knowledge. And his technology goes further. The scientific evidence now points to something so complex, it shocked the archaeologists who found it. On his spear, he has a hafting of birch bark tar. This is not just pine sap. This is a complex synthetic adhesive. To make it, you have to heat birch bark in an oxygen-deprived environment, like a sealed container or underground, to over 340 degrees Celsius. It's a dry distillation process. This is not an accident. You don't discover this by poking a stick in a fire. This is chemistry. It is arguably the first industrial process in human history, and they were doing it 200,000 years ago. You follow him back to his small clan shelter. A cave mouth, perhaps, or a hut built from mammoth bones. You see his family. And here, the last vestiges of the brute myth die. They are human. We have found Neanderthal burial sites, like the Old Man of Shanidar in Iraq. He was old, crippled, missing an arm, and had been blind in one eye for decades before he died. He could not have survived alone. His clan fed him, protected him, and cared for him for his entire life. This is compassion. This is empathy. We have found the remains of eagle talons, carefully notched and worn as jewelry. We have found fringe evidence of pigments, manganese and ochre, that seem to have been used for body paint or decoration. And perhaps most profound, scholars still argue over this, but at a site in France, Brunicle Cave, Neanderthals walked 300 meters into the total darkness of a cave, broke off stalagmites, and arranged them into perfect, deliberate circles, burning fires on top of them. Was this a ritual? A shrine? A meeting place? We will never know. But it is an act of profound, symbolic, and spiritual thought. This is the person who ruled the Ice Age for over 250,000 years. They didn't just survive the cold, they thrived in it. They were the apex predator. They hunted mammoths. They survived multiple glacial cycles, not just this last one. They watched the ice come, and they watched it go, over and over. They were the ultimate survivors. And then, about 45,000 years ago, from the south, a new human arrived. A tall, lanky, tropical ape, completely unfit for the cold. And that new human was us. You are watching the Neanderthal, the master of the Ice Age, in his element. And then, from the south, a new shape appears on the landscape. They come in small bands, following rivers north into the cold. This is Homo Sapiens. This is us. They arrive in Europe around 45,000 years ago, and in every physical way, they are the wrong animal for this world. They are a tropical ape. They are tall, lanky, and slender. Their bodies are radiators, built to shed heat on the African savanna, not to conserve it in a blizzard. Their noses are small, their chests are narrow. If you put a Sapiens and a Neanderthal side by side in a blizzard with no clothes, the Neanderthal, with his furnace-like body, wins. Every time. And yet, you are watching the replacement. Over the next 10,000 years, the Neanderthals, who ruled this continent for 250,000 years, will vanish, and these lanky, out-of-place newcomers will take over the entire planet. This is the great central mystery of our own species. Scholars still debate the exact reason for this replacement. Was it violent conflict? Did we bring new tropical diseases that their immune systems couldn't handle? Or did we just outcompete them? The answer, most scholars now believe, is that we didn't win with muscle. We won with culture. We brought a new kind of technology, a new way of thinking that gave us a critical, fatal edge. We didn't adapt our bodies to the cold. We bypassed our bodies with our minds. This is the Upper Paleolithic revolution, and it's a revolution in software, not hardware. You watch a Sapiens hunting party. They are not built for close-quarters combat like the Neanderthals, whose skeletons show the same pattern of rodeo rider injuries from getting too close to their prey. These new humans are cowards, and they are smart. One of them is holding a new, game-changing piece of technology. It's an atlatl, or a spear thrower. It's a simple-looking stick, about a foot long, with a hook on one end. But it's a mainstream historical fact that this was a profound leap. It's an extension of the human arm. By using this lever, a hunter can throw a spear faster, harder, and most importantly, farther than a Neanderthal ever could by hand. It's the difference between having to be 10 feet from a mammoth and being 60 feet away. It's the difference between a high-risk stab-and-prey hunt and a lower-risk projectile-based kill. It's a force multiplier. But the atlatl isn't even the most important invention. The true game-changer, the quirky tidbit, that is arguably the most important piece of technology in human history after the control of fire, is something you find back at their camp. It's a sewing needle. It's tiny. It's carved from a sliver of mammoth ivory or reindeer bone. It has a sharp point, and at the other end, a tiny, painstakingly drilled eye. This one tiny tool represents a conceptual leap that the Neanderthals, for all their intelligence, never seem to have made. Neanderthals had hides. They had scrapers. They almost certainly wore clothing, but they were simple draped ponchos, or hides, tied together. The eye of the needle changes everything. It allows you to stop draping and start tailoring. It allows you to take multiple pieces of hide and sew them together with fine sinew, creating fitted garments. It allows you to invent trousers. It allows you to invent sleeves. It allows you to invent parkas with hoods. It allows you to invent boots lined with fur. This is the key. A Neanderthal in a draped poncho is always leaking heat. A Sapiens in a tailored, multi-layer, fur-lined parka and trousers combination is encased in a personal, portable microclimate. They can stay warm and dry. They are not just surviving the cold. They are impervious to it. They can stay out hunting longer. They can be more mobile. They can follow the herds farther. That tiny needle is the key that unlocked the entire Arctic world. And there's one last, invisible advantage. You look at the jewelry these new humans are wearing. It's a necklace made of seashells. But this camp is 800 kilometers inland. You look at the flint they are using. The scientific evidence, the chemical signature, shows it's from a quarry 300 kilometers in the other direction. This is the final piece of the puzzle. Homo sapiens had social networks. They didn't just live in their own small, isolated family clan. They were part of a tribe, a vast, sprawling network of other humans, connected by trade, by gift-giving, by shared rituals, and probably by marriage. That seashell necklace isn't money. It's a social marker. It's a friendship bracelet that connects this group to another group hundreds of miles away. This network is the ultimate insurance policy. If your herd of reindeer fails to show up, you starve. But if you're a Sapiens, you can send a messenger 100 kilometers to your cousins by the sea, and they can send you dried fish. This sharing of information and resources, this social safety net, is a buffer against the Ice Age that no Neanderthal clan ever had. For a time, the two coexisted. We know from genetic sequencing that they interbred. Most modern humans outside of Africa carry between 1 to 4% Neanderthal DNA. They were not monsters to us. They were people. We met them, we lived with them, and we had children with them. But in the end, the combination was fatal. The Sapiens' software, the projectile weapons, the tailored clothing, and the vast social networks gave them an edge that was, over a few thousand years, insurmountable. They simply had more children who survived. They filled the landscape. And the original people of the ice, the masters of the cold, slowly, tragically, faded into the snow. We've seen the technology of these new Homo sapiens, the needles, the atlatls, the social networks. We know how they survived. But now it's time to see who they were. We have to move past their tools and into their minds. And to do that, we have to go underground, into the dark. The year is 1994. 3 French cavers, Jean-Marie Chauvet, Eliette Brunel, and Christian Hilaire, are exploring the cliffs of the Ardèche Valley in southern France. They feel a slight draft of air coming from a small, unassuming hole in the rock. Pushing aside rubble, they squeeze their way through a narrow, dark passage. It opens up. They descend into a massive, silent, black chamber, their headlamps cutting through a darkness that has been absolute and unbroken for 20,000 years. You are with them. You are one of the first humans to enter this place since the rockfall that sealed its entrance during the Ice Age. The air is still, cold, and heavy. The silence is perfect. It's not just quiet. It's the sound of a sealed tomb, a place outside of time. The only sound is your own breathing and the crunch of calcite crystals on the floor under your boots. You shine your headlamp around. The floor is littered with the bones of cave bears, some of them arranged in strange patterns. A massive, fossilized cave bear skull is sitting on top of a large rock, as if placed there deliberately. And then you lift your light to the walls, and your heart stops. This is not crude. This is not primitive. This is not a caveman scrawling stick figures. You are standing in a gallery that would rival the Renaissance. The wall is alive. A massive panel explodes in a riot of movement. A pride of lions, 13 of them, is surging across the rock. They are hunting. They are not just drawings. They are portraits. You can see the tension in their shoulders, the focused, predatory gaze. The artist has used the bulge of the rock itself to give the lead lion a sense of 3D, muscular weight. They've used charcoal to create shading, perspective, and a sense of fast-forward motion, with multiple heads drawn to show a flicker of movement. You move your light. Your hand is trembling. You are in a lost world, looking at a mainstream historical fact that is also a spiritual revelation. This is Chauvet Cave, and the scientific evidence, carbon dating of the charcoal, shows it is over 32,000 years old. This is not the end of Paleolithic art. This is the beginning. This is the work of those very first sapiens who arrived in Europe, the ones who were still living alongside the Neanderthals. You walk deeper. The only light is the small, flickering flame of the animal fat lamp you're imagining they held. A tiny, smoking wick of moss floating in a hollowed-out stone bowl filled with rendered mammoth or bear grease. The flickering light is the key. In this unsteady, dancing, living light, the paintings move. The shadows leap. The multiple heads of the lions, the 8 legs of a single bison. They're not mistakes. They are animation. They are the world's first cinema. In the flickering firelight, these animals would have appeared to run, to breathe, to hunt, to live. And the subjects, it's not what you'd expect. You're not seeing paintings of people or trees or rivers. You are seeing a who's who of the Ice Age's most powerful and terrifying creatures. The megafauna. There are the mammoths, their tusks drawn in perfect, sweeping curves. There are the woolly rhinos, their heads down, their massive blade-like horns clear as day. There are the giant deer, the megaloceros, their antlers branching across the ceiling. And there are the predators, the lions, the bears. These are not the animals they ate every day. The bones in their camp rubbish piles are almost all reindeer and horse. These are the animals they feared, the animals they respected, the animals that held power. This is not a menu. This is a pantheon. So the great central question, why? Scholars still argue about this, and they will for as long as we are a species. There is no one simple answer, and it's probably a mix of everything. Was it hunting magic? The old classic theory. That if you capture the animal's image on the wall, you will have power over it in the hunt. Sympathetic magic. Maybe. Was it a great hall? A place for the whole clan to gather in the deep of winter, a campfire for the soul, where the elders told the great stories, the myths of the tribe, using the paintings as their visual aids. And this, they would say, pointing with the firelight, is how the first lion stalked the great rhino. Or was it something deeper? Was it shamanism? Were these caves the veil between our world and the spirit world? Was this a place where a shaman, perhaps in a trance, would journey into the rock itself, contacting the spirits of the animals, painting their visages as a record of his journey? We will never, ever know. But there is one last quirky tidbit that adds a layer of profound, goosebump-inducing mystery. It's the acoustics. Recent studies of these caves, Lascaux, Chauvet, and others, have found a shocking correlation. The best paintings are not in the most visible places. They are not in the big, open entrance halls. They are often in the deepest, most difficult to reach, out-of-the-way chambers and narrow passages. And these exact spots, the places with the most paintings, are also the places in the cave with the most resonant acoustic properties. Stand in one of these painted chambers. Sing, chant, clap your hands. The sound will echo, sustain, and amplify, turning your single voice into a booming, otherworldly chorus. The rock itself sings back to you. Now imagine you are that Ice Age human. You have walked a kilometer into the total, absolute, sensory-depriving blackness. The only sound is the thump of your own heart. You light your lamp. You stand in this resonant chamber. You begin to chant. And the cave answers. It feels for all the world like the rock is alive, like a spirit is present. Is it any wonder that this is the spot they chose? That this is where they painted the masterpieces? They weren't just decorating. They were perhaps singing to the animal spirits that they believed lived within the rock itself. This is not the mind of a caveman. This is the mind of an artist, a philosopher, a mystic. This is the software of Homo sapiens. This is the profound spiritual and intellectual life that defined them and us. The art of Chauvet or Lascaux shows us the grand spiritual life of these Ice Age people, their gods, their myths, their fears. But what about their social life? What about the value of an individual? To see that, we must leave the caves of France and travel 2,500 kilometers east to the frozen plains of Russia. You are at a site called Sunghir, just outside the modern city of Vladimir. The year is 1964. Archaeologists are excavating a simple Paleolithic campsite. They are digging through a layer of permafrost from about 34,000 years ago. They find the usual: stone tools, campfire ash, the bones of reindeer and mammoths. And then they find the graves. The first one they unearth is that of a man, likely in his 50s. He is buried with what appears to be incredible honor. He is covered in jewelry. His clothes, long since decayed, were clearly adorned with hundreds of hand-carved, polished mammoth ivory beads. Bracelets of mammoth ivory encircle his arms. A pendant, a small, flat stone with a single red dot, rests on his chest. This is a spectacular find in its own right. It's a mainstream historical fact that Paleolithic people buried their dead. But this level of ornamentation is rare. It tells us this man was important. A leader, a great hunter, a shaman. But then, the archaeologists dig deeper, just below this man's grave. And what they find is so unexpected, so beyond the bounds of what was believed about Ice Age society, that it changes the field of archaeology forever. It's another grave. Inside, lying head to head, are the skeletons of two children. One is a boy, about 12 or 13 years old. The other is a girl, about 9 or 10. Modern DNA analysis, by the way, has confirmed the skeleton's sex. And they are not just buried. They are entombed. You're looking at a scene of staggering, heartbreaking, and profound love and effort. The children are drenched in ivory. Their clothes were not just decorated, they were encrusted with beads, sewn on in dense elaborate ornamental patterns. We are not talking about a necklace. We are talking about thousands upon thousands of beads, forming a complete, shimmering, pearly white funeral garment. On the boy's chest lies a fringe tidbit of artistic mastery, a flat, carved ivory disc, polished to a shine. On his head he wears a cap or diadem that was sewn with fox teeth, over 250 of them. He has an ivory belt, and at his side, a small, carved ivory mammoth. A toy, a guardian. The girl is just as adorned. Her beaded cap is just as elaborate. At their feet, placed as if for a long journey, are other stranger offerings. Enormous, perfectly straight spears, made not from wood, but from mammoth tusks. This is the quirky tidbit that breaks your brain. A mammoth's tusk is, of course, curved. To make these 2-meter-long, perfectly straight spears, these people had to invent a technology that we still don't fully understand. The leading theory is that they must have split the tusk, probably by wedging, and then soaked and steamed the long strips of ivory, perhaps in a steam pit, or by wrapping them in wet hides over a fire, until they were pliable enough to be straightened in a press. Then they would have to be dried, polished, and hardened. This is not primitive tool making. This is advanced materials science. This is artisanship, that would be the envy of a master cabinet maker today. But the real, gut-punching, paradigm-shifting detail isn't the spears or the fox teeth. It's the beads. The scientific evidence here comes from experimental archaeology. Scientists in a very famous study tried to replicate these beads. They took a chunk of mammoth ivory, and using only the stone burin tools that these people had, they tried to make one bead. This is the process. You have to chop the tusk. You have to chisel off a small, rough blank. You have to drill the tiny, perfect hole. How? With a hand-spun flint-tipped drill? Then you have to polish it, probably by rubbing it in a groove of sandstone, then buffing it with a piece of oiled leather. The scientists found that to make one single bead took, on average, 45 minutes to 1 hour of dedicated, skilled labor. Now, do the math. There are over 10,000 beads in this single double grave. 10,000 beads. At, let's be generous, 45 minutes per bead. That is 7,500 hours of work. That is one person working 8 hours a day, every single day, for over 2.5 years. And this is where our entire hand-to-mouth image of the Ice Age shatters. This is not a society living on the edge of starvation. This is not a group of people who are just surviving. A society that is just surviving does not, cannot, spend thousands of hours of skilled labor, calories, and time on funeral decorations for children. This is, without a doubt, a society of surplus. They had enough food. They had enough security. They had so much surplus that they could afford, in a group of, say, 30 people, to have their best, most skilled artisans sit down and do nothing for months on end but carve beads. And that leads to the final, profound, and openly debated question. Who were these children? Why them? The 50-year-old man buried above them was important, yes, but the children received the most lavish, time-consuming, and resource-intensive burial on the entire planet for this time period. Scholars still argue over this. Were they special because of who they were, or because of how they died? One theory. They were the children of a chief or a big man. This would be the earliest evidence of hereditary social status. That even in death, these children were princes and princesses. And their status, inherited from their father, demanded this level of community-wide sacrifice. If true, this pushes back the origins of social inequality by 25,000 years. Another, more tragic theory. They were sacrifices. Perhaps they died of a simultaneous, tragic accident. Or perhaps in a dark, ritualistic twist, they were sent to the afterlife to accompany the chief buried above them. The boy, by the way, has a single fatal-looking puncture wound in his first thoracic vertebra. The girl has no obvious signs of trauma. We will never know. But we stand here, 34,000 years later, looking at the evidence. We are looking at a society with a clear, complex social structure. We are looking at a society with incredible technological and artistic mastery. And we are looking at a society with a profound belief system, a belief in an afterlife so strong that they were willing to invest thousands upon thousands of hours of their present lives to equip these two small children for the journey ahead. This is Sunghir. It is not a grave of cavemen. It is the tomb of Ivory Princes. You're standing at the edge of your Sapiens hunting camp, lit by the flickering glow of a fire. It's deep in the night. The cold is a physical presence, a wall of blackness just beyond the light. Out there in that dark are the others, the mammoths, the rhinos, the lions. They are your food, your terror, your gods, your raw materials. The story of your relationship with them is one of conflict, of competition, and as we'll see, of extinction. But as you stare into the darkness, you see a pair of eyes reflecting the firelight. They are not the eyes of a mammoth. They are the eyes of your great rival, your direct competitor, the other apex social predator of the Mammoth Steppe, the grey wolf. You and the wolf are in the same business. You both hunt in cooperative, intelligent packs. You both target the same prey: the reindeer, the horses, the bison. In any sane world, you should be mortal enemies, fighting to the death over every single kill. And yet, the story that unfolds here, at the edge of the firelight, is not one of conflict. It's the other great survival story of the Ice Age. It is the story of the first ally. This is the mainstream historical fact that is so crucial to understand. This did not happen after the Ice Age. This is not the story of a civilized farmer taming a wild beast. This is a gritty, desperate Ice Age pact made by hunter-gatherers in the deep cold 30,000 years ago, long before we ever planted a single seed. So, how did it happen? For decades, the romantic image was of a brave hunter finding an abandoned cub and raising it. This is probably wrong. The truth, scholars now argue, is far more interesting. It wasn't taming, it was self-domestication. The theory, often called the friendly wolf hypothesis, goes like this. In any given wolf population, there is a natural variation in personality. Most wolves are, correctly, terrified of you. You are a new, weird, two-legged predator with fire and sharp sticks. Most keep their distance. A few are hyper-aggressive, and if they try to challenge you, they get a spear for their trouble and are quickly weeded out of the gene pool. But in that population, there are a few quirky individuals. They are the ones with a slightly lower than normal fear response. They are just bold enough and not aggressive enough to be curious. You're at your camp. You've just butchered a reindeer. You throw the bones and the scraps just beyond the ring of light. The normal wolves are too scared to approach. But that one bolder wolf, the friendly one, waits. When you're asleep, it creeps in, its belly to the ground, and gets a free, calorie-rich meal. It survives the winter better than its packmates. It has pups, and it passes on that friendly gene. The humans, for their part, tolerate this. Why? Because this scrawny, tamish wolf is incredibly useful. First, it's a free garbage disposal. It cleans your camp of scraps, which means you're not attracting scarier things, like a cave hyena, a lion, or a giant short-faced bear. Second, it's the perfect free alarm system. This wolf pack, now living in symbiosis with you, considers your camp its territory. Nothing, absolutely nothing, can get within 200 yards of your camp, day or night, without this new proto-dog pack going absolutely ballistic, giving you a crucial, life-saving warning. Over generations, this pact is cemented. The wolves that are best at reading human cues, a glance, a pointed finger, a shift in tone, get the most scraps. They thrive. The humans who are best at working with these new allies, they also thrive. We have seen the scientific evidence for this exact process. It's the famous 20th century Soviet fox experiment. A scientist, Dmitry Belyaev, took wild silver foxes and for decades bred only the ones that showed the least fear of humans. Within just a few generations, the foxes didn't just become tame. Their bodies changed. Their coats became spotted, Their tails began to curl. Their ears got floppy. This is the domestication syndrome. By selecting only for the friendliest personality, Belyaev was accidentally selecting for a whole suite of juvenile, puppy-like traits, a process called neoteny. That is the quirky tidbit at the heart of your pet. Your golden retriever is, in essence, a wolf stuck in a permanent state of puppyhood, because for 30,000 years we have been selecting for the friendly ones, the ones that were brave enough to come to the fire. Scholars still argue over the exact when and where. Was it a single event in Siberia, or did it happen multiple times, independently, in Europe and Asia? The genetic trail is complex, but the oldest unambiguous dog-like skull we have is over 31,000 years old. This is an Ice Age partnership. This alliance gave Homo sapiens a massive advantage. You are no longer just a pack of humans. You are a super pack. You have allies with noses that can smell a reindeer a mile away, ears that can hear a threat in the dead of night, and legs that can run down prey you would have lost. They can track, they can corner, they can guard your camp and your children. This is the emotional counterpoint to the entire Ice Age story. The relationship with the mammoths, the rhinos, the smilodon. That is a story of extinction. They are ghosts, but this one relationship is different. This is the one rival, the one great megafauna that we did not destroy. We joined them. It's the story of how two apex predators, in the brutal cold of the LGM, decided that it was better to be friends than to be enemies. And that single decision, that first alliance, helped us conquer the world. You're a Homo sapiens. You have the needle, the atlatl, the fire, and now, the dog. You have become the undisputed apex superpack of the planet. You have followed the herds, the great rivers of protein, across the entire Mammoth Steppe, from the shores of France to the far frozen northeastern edge of Siberia. You have conquered the old world, and you get to the edge of the world, and you find it's not the edge. You are standing on the coast of Siberia, but the ocean is not there. Remember that 120-meter sea level drop? The Bering Strait does not exist. You are looking out at a vast, cold, dry, and habitable land. This is Beringia. Let's kill the ice bridge myth for good. This was not a narrow, frozen, slippery bridge that people sprinted across in a single generation. This was a continent. Just like Doggerland connected Britain to Europe, Beringia was a massive, 1,000-mile-wide landmass that connected Asia to America. This is the highway for the last great migration in human history. But it wasn't just a highway. This is the quirky tidbit that has become the central accepted theory. It was also a refuge. This is the Beringian standstill hypothesis. The scientific evidence from genetics, both human and animal, suggests that people didn't just pass through. They lived here. They lived on this lost continent of Beringia for thousands of years. Why? Because they were trapped. To the west, back in Siberia, the glaciers were advancing, cutting them off. And to the east, in what is now Alaska, they were blocked by a sight that would make your heart stop. They were staring at a wall of ice that dwarfed even the Alps. They were blocked by two separate ice sheets that had grown so enormous they met in the middle. From the east came the massive Laurentide ice sheet, the one centered on Hudson Bay. From the west came the Cordilleran ice sheet, a second independent sheet that covered the entire Rocky Mountain range. They had zipped together, forming a single unbroken 3,000-kilometer-long barrier of ice, walling off the entire rest of the Americas. So the first Americans were these Beringians, living in this lost, ice-free land, hunting mammoths and horses for generation after generation, waiting. Now, how did they get south? This is where we have one of the greatest flip-flops in modern science. The mainstream historical fact that was taught for 50 years was the ice-free corridor theory. The idea was simple. Around 13,500 years ago, as the planet just began to warm, these two great ice sheets unzipped, melting back just enough to open a narrow, non-glacial corridor that ran from Alaska down through what is now Alberta, all the way to the Great Plains. The Beringians, the theory went, saw this opening, and for the first time, they could walk south. They poured through this corridor, and within a few hundred years, populated 2 entire continents. It's a great story, and it's almost certainly wrong. This is the new theory, and it's the one that has completely replaced the old one. The Kelp Highway. Scholars still argued about this for decades, but the evidence became undeniable. The problem with the ice-free corridor was twofold. First, carbon dating showed it didn't open early enough to explain the oldest human sites we were finding. Second, even when it did open, pollen analysis showed it was a sterile, barren, miserable wasteland of gravel and ice melt. It was not a highway, it was an impassable 2,000-kilometer-long death trap with nothing to eat. So how did they get here? They didn't walk, they paddled. The new theory is that the first Americans were a coastal people. They were Ice Age mariners. They had boats, perhaps simple skin-on-frame kayaks or umiaks, and they didn't go through the ice. They went around it. They hopped down the Pacific coast. The Kelp Highway refers to the rich Ice Age ecosystem that would have existed just offshore. With sea levels 120 meters lower, there would have been a string of ice-free refuge islands and a rocky coast teeming with life. Seals, sea lions, otters, birds, shellfish, and massive edible kelp forests. It was a mainstream historical fact of resources, a buffet all the way down the coast. This theory explains the biggest problem: the smoking gun scientific evidence of Monteverde. This is an archaeological site in southern Chile, and the carbon dating is irrefutable. It is 14,500 years old. That is at least 1,000 years older than the ice-free corridor even opened. The people at Monteverde, who lived in timber-framed animal-hide huts and ate mastodon, could not possibly have walked. They must have come by boat, and they must have come much earlier. This means that after the first Americans were already settled deep in South America, a second wave of people, or perhaps the same group, moving inland, finally did walk through that ice-free corridor. And this is where we meet the most famous group. They are not the first Americans, but they are the first widespread continental culture. We call them the Clovis people. They appear on the scene around 13,400 years ago, and they are everywhere. Their calling card is one of the most beautiful and deadly inventions in human history: the Clovis point. It's a large, fluted, exquisitely napped spearhead. It's not just a point, it's a system. The flute is a channel or groove chipped from the base, allowing it to be hafted onto a spear shaft, thrown with an atlatl, with incredible shock-absorbing strength. These Clovis people were the master megafauna hunters, and when they burst onto the plains of North America, they found a world that was, for a hunter, paradise. They found a continent of giants, mammoths, mastodons, giant sloths, horses, camels. And here is the final, tragic key. All of these animals were naive prey. The megafauna of Africa and Eurasia had co-evolved with Homo erectus and Neanderthals and Sapiens for 2 million years. They knew that the small, two-legged ape with the fire and the sharp sticks was danger. They had an evolved fear. The megafauna of the Americas had never seen a human. They had no fear. They were ecologically naive. And into this Garden of Eden walked the Clovis people, the most sophisticated, cooperative, projectile-wielding, super-pack predator the planet had ever produced. It wasn't a hunt. It was a blitzkrieg. And it was the beginning of the end for the titans of the ice. You are a Clovis hunter on the plains of North America, or perhaps a descendant of the Sunghir people in Russia. The world is changing. The 100,000-year clock has ticked. The Milankovitch cycles have aligned. The super summer has arrived. The planet is finally beginning to warm. It's been happening for a few thousand years. The great ice domes, the Laurentide and the Fennoscandian, are in full retreat. They are melting. Life is good. For you as a human, this is a golden age. The brutal -40 degrees Celsius winters are easing. The forests, those scrubby Arctic willows and birches, are starting to be replaced by taller, warmer weather trees like pine and oak. The herds are plentiful. The land is greening. You are on the winning side of a global heat wave. And then, one year, the spring is late. The winter just doesn't end. You are standing in what is now Germany. You are 12,900 years ago, and the world is, for no reason you can understand, ending. This is the Younger Dryas. It is, without question, the most violent, abrupt, and terrifying climate event in modern human history. It's not a slow slide. It is a snap. The scientific evidence from the Greenland ice cores is the smoking gun. The data shows that in the span of a single human lifetime, perhaps in as little as a decade, average temperatures in the northern hemisphere plummeted. They fell by as much as 15 degrees Celsius, 27 degrees Fahrenheit, in 10 years. This is not climate change. This is an apocalypse. This is the world plunging back into a full-blown LGM-style ice age after it had already started to warm. You are that hunter. Imagine the terror. The forests of oak that were just beginning to give you acorns, they die. They are gone in a single generation, replaced by the scrubby Arctic Dryas flower, a tiny white tundra flower that gives the event its quirky name. The great herds of bison you hunted, they migrate south, or they starve. The ice, you can see it. The glaciers that had been retreating for 1,000 years stop, and they advance. They are coming back. For 1,200 years the heat is turned off. The world is plunged back into the deep freeze. What happened? This was the greatest climate whodunit of the 20th century. Scholars still argue over the trigger, with some fringe theories pointing to a comet impact. But the mainstream historical fact, the leading and most widely accepted theory, is not an alien invader. It's a flood. We have to go back to North America. The Laurentide ice sheet is melting, but it's not melting cleanly. It's a messy, chaotic, collapsing disaster. And as this 3-kilometer-high wall of ice melts, it creates lakes. We are not talking about a lake. We are talking about Glacial Lake Agassiz. This is a body of water that is almost impossible to comprehend. It's a meltwater lake, dammed up against the southern edge of the retreating Laurentide ice sheet. At its peak, it was larger than all 5 of the modern Great Lakes combined. It was bigger than the modern-day Caspian Sea. It held more water than all the lakes on Earth today, and this entire continent-sized lake was being held in place by a single, rotting, 500-meter-high dam made of ice. 12,900 years ago, the dam broke. We don't know if it was an earthquake or if the water just finally melted its way through. But it burst. The entire lake, 160,000 cubic kilometers of fresh, cold water, catastrophically drained. It was not a flood. It was a deluge of biblical proportions. It was a flow of water so immense, it was 10 times the flow of the Amazon River. It scoured the land, carving out entire river valleys in a matter of months. And all of this water, this continent of fresh, cold water, poured in one single catastrophic pulse into the North Atlantic Ocean. And this is where it pulled the trigger. It broke the planet's circulatory system. You have in the Atlantic Ocean a conveyor belt of heat. It's called the AMOC, Atlantic Meridional Overturning Circulation. It's the Gulf Stream. Warm, salty water from the tropics flows north, releasing its heat into Europe, which is why London is not as cold as Siberia, despite being at the same latitude. As this water releases its heat, it gets cold. And because it's salty, it's very dense. It sinks to the bottom of the ocean, and then it flows back south in a great, looping global conveyor belt. But now, you've just dumped a lake the size of a sea, made of fresh, cold water, right on top of the sinking point. Fresh water is not dense. It doesn't sink. The conveyor belt stopped. The AMOC, the heat pump for the entire northern hemisphere, shut down. The heat was off. Europe plunged back into the Ice Age. The Younger Dryas is the single most terrifying and important lesson the Ice Age can teach us. It is the perfect, horrifying example of a climate tipping point. It proves that the Earth's climate does not change slowly and gracefully. It changes in jumps. The system can absorb stress, and absorb it, and absorb it, until it hits a single invisible line. And then, in the blink of an eye, the entire operating system can flip to a completely new and deadly state. That catastrophic draining of Lake Agassiz, the one that triggered the Younger Dryas, was the final act of the Ice Age's chaotic collapse. But it was not the only one. The tipping point lesson was not an isolated event. For 1,000 years before that, as the ice sheets were first beginning to melt, the planet was already rehearsing this kind of disaster, just on a more local scale. You're traveling back a few thousand years to about 15,000 years ago. You are in North America, but on the other side of the continent. You're in what is now the state of Washington, or Idaho, or Montana. You're standing on a high ridge, looking out over a landscape of rolling, grassy hills. And you are, for all intents and purposes, standing on a beach. This is the story of J. Harlan Bretz, and it's one of the great fringe tidbit sagas of 20th century science. Bretz was a geologist in the 1920s, and he was obsessed with this landscape. It just didn't make sense. The landscape was wrong. It was scarred, ripped apart, and scoured on a scale that was unimaginable. He called it the channeled scablands. This is what he saw. He saw coulees, which is just a word for a dried-up river channel. But these were not river channels. They were canyons, hundreds of feet deep, blasted straight through solid basalt bedrock that would start nowhere and end nowhere. He saw giant 50-foot-high ripple marks, not the kind you see in the sand at a beach, but mile-long ripples made of 300-ton boulders. He saw erratic boulders, rocks the size of a house, that had come from a quarry 500 miles away, dropped in the middle of a random field. He saw dry falls, like a 400-foot-high, 3-mile-wide version of Niagara Falls, with no water. The geology was violent, and in the 1920s, there was only one mainstream historical fact in geology: uniformitarianism. The present is the key to the past. All geological change is slow, gradual, and constant. A river slowly, over millions of years, carves a canyon. J. Harlan Bretz stood in the middle of this scoured landscape and said, "You are all wrong." He proposed a theory so outrageous, so unscientific, so fringe, that it ruined his career. He said this landscape was not formed over millions of years. He said it was formed in days. He proposed a flood of such impossible biblical proportions that it made the draining of Lake Agassiz look like a leaky faucet. The scientific community ridiculed him. They mocked him. They called him a catastrophist, a heretic. "Where," they asked, "could you possibly get that much water?" Bretz, at the time, didn't have the answer. He just pointed to the scientific evidence on the ground and said, "I don't know where the water came from. I just know that it was here." It took 40 years for him to be proven right. It wasn't until the 1950s and 60s, with the advent of aerial photography and satellite mapping, that geologists finally found his smoking gun. They found the source of the water. It was Glacial Lake Missoula. It was another ice-dammed lake, this one in Montana. The Cordilleran ice sheet, the one over the Rockies, had advanced, plugging a river valley with a 2,000-foot high wall of ice. Water built up behind it, flooding the entire mountain valley system of western Montana. And just like Lake Agassiz, this ice dam was not stable. The pressure of the water would build up until it was so great that it would lift the 2,000-foot high ice dam off its foundations. The water would start to leak, and then gush from the bottom of the glacier. The dam would fail. The entire lake would drain in 48 hours. You are standing on that ridge. You are watching a wall of water, 400 feet high, moving at 80 miles per hour. It is a temporary river that has more water in it than all the other rivers on Earth, combined, times 10. It is not water. It is a liquid wrecking ball. It is a slurry of water, ice, mud, and boulders the size of cars. And it is moving with such force that it peels the top 100 feet of soil and rock off the continent and blasts it into the Pacific Ocean. It rips the landscape down to the bare basalt bedrock. It carves those 400-foot deep canyons. In 2 days, the flood roars across Washington state. And then it's gone. And here is the most terrifying scholars still debate part. The ice dam, its plug now gone, would settle back down. The ice would advance. The river would be plugged again. The lake would refill, and it would burst again. The geologic record shows this happened dozens of times, perhaps 100 times. For 2,000 years, this part of the world was in a repeating cycle of unimaginable catastrophe. This is the true story of the Great Thaw. It was not a gentle, peaceful spring day. It was a chaotic, violent, and terrifying series of tipping points. It was a world of collapsing ice dams, of continental-scale floods, and of sudden, decade-long apocalypses like the Younger Dryas. It was the messy, violent, and catastrophic death of the glacial world. And in this chaos, the great titans of the ice, the ones who had survived for 100,000 years, were about to face their end. The Younger Dryas, that 1,200-year-long apocalypse, finally breaks. The heat pump in the Atlantic, the AM-Mock, lurches back on. The nightmare is over. And now, 11,700 years ago, the warming is real. This is it. The great thaw is final. You are standing on the precipice of our modern world. The ice sheets are in their final terminal retreat. The Holocene, our current stable, warm, interglacial period, has begun. This should be a golden age for all life. The cold is gone. The land is greening. The long winter is over. But it's not. This is not a story of new life. This is the story of a mass death. As this new, warm, wet world is born, the titans of the Ice Age vanish. In the span of just a few thousand years, a geologic blink, they are gone. The mammoths, the woolly rhinos, the smilodon, the glyptodon, the giant ground sloths, the dire wolves, the giant short-faced bears, the megaloceros. All of them gone forever. This is the Quaternary extinction event. It is the single greatest and most profound mystery of the last 100,000 years. And it has left us with a bitter, two-sided question that we are still arguing over today. What did it? Was it us, or was it the climate? This is the great climate versus humans debate, and it's the central, tragic, open scholarly debate of the Ice Age. Let's start with Team Climate. The argument is simple, elegant, and powerful. The giants weren't murdered, they starved. Their entire world was pulled out from under them. Remember the Mammoth Steppe, that magic carpet of food. That vast, dry, windy, dusty, continent-sized plain of nutritious grasses and forbs. That was the engine of the Ice Age. The new Holocene world killed it. The new world was warm and wet. The wind stopped, because the ice sheets were no longer giant, cold-weather, high-pressure zones. The dust, that free, mineral-rich fertilizer, stopped. And the rain. The rain started. As the world got wetter, that dry, firm steppe, the Serengeti of the Ice Age, turned into a bog. The scientific evidence from pollen cores is the smoking gun for this argument. You can literally watch the change in the soil layers. The pollen from the nutritious steppe grasses and forbs vanishes, and it is replaced by two things. In the north, it's replaced by tundra, a wet, acidic, waterlogged bog dominated by low-nutrition mosses, lichens, and dwarf shrubs. A mammoth or a rhino can't live on moss. It's like trying to feed an elephant on wet cardboard. In the south, it's replaced by forests. As the CO2 levels rose and the air got wetter, dense, coniferous forests exploded across the landscape, closing in the open plains. A woolly mammoth, with its giant grinding plate teeth, is not a browser. It can't live by nibbling on pine needles and tree bark. So the climate argument is that the magic carpet of food was simultaneously rolled up from one end by the boggy, useless tundra, and from the other end by the dense, inedible forests. The all-you-can-eat buffet of the LGM was gone, replaced by a food desert. The megafauna were trapped. Their populations fragmented into smaller and smaller pockets, where they starved one by one. It's a clean, tragic, no-fault theory, until you look at the clocks. Now meet Team Human. Their argument, the Overkill Hypothesis, is just as simple and just as brutal. The climate theory is a nice story, but the timing is too suspicious. These animals, the mammoths, the rhinos, the sloths, were tough. They were not fragile, hothouse flowers. They were survivors. They had already lived through other interglacial warm periods. They had seen forests and bogs before, and they survived. Why was this one interglacial, the Holocene, so special? What was the one new ingredient in the mix that had never been there before? US. Everywhere on the planet you look, the extinction and the arrival of Homo sapiens are perfectly aligned. In Europe and Asia, the mammoths and rhinos held on for a long time. They coexisted with Neanderthals and sapiens for 20,000 years. Our hunting was just one more pressure they had to deal with. But in the Americas, this is the mainstream historical fact that gives Team Human all its ammunition. In the Americas, there were no humans. The megafauna lived in a paradise, free of the two-legged predator, for 1 million years. Then, around 14,000 to 13,000 years ago, what happens? 1. The Clovis people, the master hunters, arrive. 2. The extinction happens. And it happens fast, not over 10,000 years. It happens in the fossil record in less than 1,000. It's a blitzkrieg. The naive prey that had no fear of humans were simply, systematically, and rapidly hunted to extinction. The quirky tidbit here is the last stand. The very last remnant population of woolly mammoths were dwarves. They lived on Wrangel Island, a remote, frozen rock in the Arctic Ocean, cut off from the mainland and from humans by the rising sea levels. They survived there, in this isolated, human-free, lost world, until 4,000 years ago. Let that sink in. The pyramids of Giza were already built, while a tiny dwarf population of woolly mammoths was still alive. And when did they finally go extinct? Almost exactly when the first archaeological evidence of humans arrives on Wrangel Island. So, who was it? In the end, as with all great debates, the answer is both. The 1-2 punch hypothesis is what most scholars now accept. Punch 1. Climate. The warming, wetting world stressed the populations. It did destroy their main food source, the steppe. It did fragment their habitats, turning a single, massive superpopulation into a dozen small, isolated, and vulnerable inbred pockets. The giants were on the ropes. They were sick. They were struggling. Their numbers were low. Punch 2. Humans. And into this world of stressed, weakened, and fragmented populations walks the most efficient, cooperative, projectile-wielding predator the planet has ever seen. We didn't have to kill all of them. We just had to be good enough at killing the babies. We just had to hunt them just faster than their slow, elephant-like reproductive rates could replace the loss. We were the tipping point. We were the final killing blow. And this leads to the last sad question. Who survived? Why? Are there bison? Why are there deer? Why are there moose? The survivors were the weeds. They were the fast breeders. A mammoth, like an elephant, has a 22-month gestation. It has one calf. It takes 15 years for that calf to mature. This is a slow reproductive cycle. A bison or a deer, they can have a calf every single year. You can hunt bison all you want. They just make more. The survivors were the ones who could, quite literally, out-reproduce our spears. The slow, majestic, K-selected giants had no chance. We had entered the world, and the age of titans was over. The titans are gone. The world has been cleansed by climate and by spear. The great continental ice sheets are a memory, and you are standing at the dawn of a new, stable age. This is the Holocene. It's our age. The 11,700-year-long interglacial period that we call human history. The climate is now warm and, most importantly, stable. The violent, chaotic lurches of the Great Thaw, the Missoula floods, the Younger Dryas, are over. The planet's systems have settled into a new, predictable, gentle rhythm. And in this new, stable world, the Milankovitch cycles, the great clockwork of the cosmos, are still ticking. They no longer have the power to trigger a global ice age. We're at the warm peak, after all. But they do still have the power to change the world, and they are about to perform their most incredible magic trick, one that will create and then destroy a paradise. You are traveling to the largest, driest, most famously barren place on Earth, the Sahara Desert. You are standing in the middle of it, 6,000 years ago. And you are not in a desert, you are in a savanna. You are standing on a plain of green, waving grass. You are in the shade of an acacia tree. In the distance, you see a herd of giraffes, their long necks pulling leaves from the high branches. You see elephants. You see hippos, wallowing in a deep, wide river that, well, that isn't supposed to be there. This is the African humid period, or the Green Sahara. It's a mainstream historical fact, and it is one of the most dramatic, real-world examples of how the planet's orbital waltz directly creates a world. What happened? The culprit is our old friend, the 26,000-year wobble cycle, precession. Remember how it works? It determines when our seasons happen relative to our closest or farthest point from the sun. Right now, in the 21st century, the northern hemisphere has its summer when the Earth is farthest from the sun, aphelion. This gives us mild, cooler summers. But 8,000 to 6,000 years ago, the wobble was on the other side. The northern hemisphere had its summer when the Earth was closest to the sun, perihelion. This created super summers. The sun's energy beating down on North Africa during these super summers was 7 to 8% more intense than it is today. This intense heat created a massive low-pressure zone over the land. This heat low was so powerful, it sucked in unimaginable amounts of moisture from the tropical Atlantic Ocean, dramatically strengthening and redirecting the West African monsoon. It was a runaway feedback loop of the best kind. The monsoon surged north, thousands of kilometers farther inland than it does today, bringing life-giving rain to the entire Sahara. The rain fell. The grasses grew. The grass, the albedo, the color of the land, was darker than the bright, reflective sand, so it absorbed even more heat, which strengthened the low-pressure system, which sucked in even more rain. For 5,000 years, the Sahara bloomed. The scientific evidence is overwhelming. It's in the deep-sea sediment cores off the coast of Africa. In the layers corresponding to this period, the fringe tidbit is what's missing. The dust. For 5,000 years, the dust blowing off the Sahara stopped. The desert was gone. It's in the pollen, preserved in the mud at the bottom of ancient, now dry lake beds, that shows us the plants that lived there, savanna grasses, shrubs, and even trees. It's in the bones of the animals that lived there, giraffes, elephants, hippos, crocodiles. And most poignantly, it's in the art. This is not a lost world. It was a populated world. Humans who had been huddled in the Nile Valley now spread out across this new green paradise. And they painted. Deep in the most desolate, barren, and sun-scorched mountain ranges of the Central Sahara, like the Tassili Nudger, you can find thousands of the most beautiful, vibrant rock paintings on Earth. They are not primitive. They are elegant, fluid, and full of life. And they show us, in a mainstream historical fact that doubles as a heartbreaking postcard, exactly what their world was like. They show people herding cattle. They show people hunting giraffes. They show people swimming. This is the Cave of Swimmers, made famous by the movie The English Patient. It is real. It is a portrait of a world that is so wet and full of life. It is, from our modern vantage point, a fantasy. But the clock never stops ticking. The 26,000-year wobble continued. The Earth's axis kept moving. Slowly, year by year, century by century, the Northern Hemisphere's summer, super summer at perihelion drifted away. The volume knob of the monsoon was being turned down. Around 5,500 years ago, the system hit a tipping point. The rain faltered. The super feedback reversed. The rains weakened, so the grasses died. The death of the grass exposed the light. Sandy soil. The light soil was reflective. It absorbed less heat. This weakened the low-pressure system, which weakened the monsoon even more, which killed more grass, which exposed more sand. It was a catastrophic runaway collapse. Scholars still argue over how fast it was. Was it a slow 1,000 S-year decline? Or, as some recent evidence suggests, did it happen fast? Did the green Sahara, this 5,000-year-old paradise, collapse back into a hyper-arid desert in as little as 200 years? For the people who lived there, it was an apocalypse in slow motion. The rivers they had fished in became trickles. The lakes they had swum in became mud flats, and then cracked, dusty graves. The herds of giraffes were gone. They were climate refugees. They were forced to leave, to migrate. And where did they all go? They were funneled by the new, expanding and merciless desert into the one place in North Africa where a reliable, permanent superhighway of water still existed, completely independent of the monsoon. They were forced by the thousands into the narrow, fertile, green ribbon of the Nile Valley. It is no coincidence, historians argue, that this is the moment, just as this massive, new, displaced population is concentrated into one fertile, crowded valley, that the pharaonic civilization of ancient Egypt, the world's first great nation-state, begins. The green Sahara died, so that Egypt could be born. The megafauna are gone. The great floods have subsided. The ice is in retreat. And the great, terrifying off-switch of the younger dryas has been, at last, flipped back on. You are standing in the quiet dawn of the Holocene. It's the mainstream historical fact that is so big, we forget it. Our entire world, our entire conception of history, is based on the 11,700 years of profound and frankly boring climate stability that began at that moment. The great violent oscillations of the 100,000-year cycle are in a pause state. The climate is warm, it's wet, and most importantly, it's predictable. For the first time, maybe ever, the rules of the planet are not being rewritten every generation. The spring will come. The summer will be warm. The winter will be cold. Repeat. This stability, this is the one ingredient that was missing from the Paleolithic. Think about it. Why didn't those brilliant sapiens at Sunghir, the ones doing materials science on mammoth tusks, invent farming? Why didn't the artists at Chauvet, with their mastery of form and perspective, settle down and plant some wheat? Because they couldn't. Not because they were stupid, but because their world was hostile to the very idea of it. Farming is, at its core, an act of faith. It's a bet. It's the bet that if you put a tiny, useless seed in the ground, the entire world will cooperate with you for the next 6 months, that the sun will shine, that the rain will fall, and that, crucially, the off switch for the entire northern hemisphere won't be flipped in the middle of July. You simply cannot be a farmer in the Pleistocene. You cannot invest your entire tribe's effort and calories into planting a field, when a random event like the Younger Dryas could wipe it, and you off the face of the earth in a decade. It's a fringe, insane bet. The smart bet, the only bet in the Ice Age, was to be mobile, to be a hunter-gatherer, to follow your food, to not be tied down. But now, in the Holocene, the bet has changed. The casino is no longer rigged. The game is stable. And so, in maybe a half-dozen places on Earth, completely independently of each other, in the Fertile Crescent, in China, in New Guinea, in the Americas, humans start to make that bet. This is the invention of agriculture, and it is, without a doubt, the most important and the most disastrous event in human history. We call it a revolution, but it wasn't. A revolution is fast. It's exciting. This was a trap. It was a slow, miserable, creeping process that took 3,000 years. It wasn't an invention. It was an accident. Scholars still argue over the exact why. Was it population pressure? Did our hunter-gatherer success just make too many of us? Or was it just a slow-motion mistake? Imagine this. You are a hunter-gatherer in the Fertile Crescent. You are living in a paradise of wild food. There are fields of wild wheat and barley just growing. You gather them. You're so successful that you stop walking. You build a little base camp, a mud hut. You're still a hunter-gatherer, but you're a sedentary one. You gather all this wild wheat. You spill some by your hut. The next year you notice more wheat is growing right there. You think, that's convenient. So you clear a few rocks. You pull a few weeds. You're not a farmer. You're just a gardener. You do this for 500 years. Your population grows. The wild fields are getting a little thin. But your garden is doing great. So you clear a little more. You start intentionally saving the good seeds, the fat ones, and planting them. By the time you realize what you're doing, it's too late. You are no longer a hunter-gatherer who gardens. You are a farmer, and your life has just gotten immeasurably worse. This is the great quirky tidbit, the dark joke of human history. We think of farming as a step up. For the individual, it was a catastrophic step down. The scientific evidence for this is written in our bones. You can take a skeleton of an 8000 BC hunter-gatherer and put it next to a skeleton of a 6000 BC farmer from the same region. The difference is shocking. The hunter-gatherer is taller. The farmer is, on average, shorter. This is the mainstream historical fact of nutritional stress. The farmers were malnourished. Their diet was worse. A hunter-gath. Era eats 30 different things in a week. Nuts, berries, fish, reindeer, herbs. It's a rich, varied, protein and vitamin-filled diet. A farmer eats wheat, and nothing but wheat. They are carb-loading their way into malnutrition. The farmer's bones are riddled with disease. We see Harris lines, marks of arrested growth from famine, porous skulls, a sign of anemia, probably from an iron-deficient diet of pure grain, and abscesses. The farmer's teeth are a disaster. They are rotted with cavities. Why? Because a diet of starchy, ground-up grain is sugar. The hunter-gatherer's teeth are, by comparison, perfect. And the farmer's back is a wreck. Their spine is compressed. Their joints are arthritic. Why? Because farming is horrible work. It is hours and hours, day after day, of back-breaking, repetitive, stooped-over labor. Hunting a mammoth is dangerous, but it's not every day. Farming is a 365-day-a-year grind. So, why? Why, if it was so awful, if it made us shorter, sicker, and more miserable, did we do it? Because it worked. It was a trap, but it was a successful one. That farmer's life was miserable, but that one, stupid, starchy, malnourished, but calorie-dense acre of wheat could feed 10 times the number of people as one healthy acre of wild forest. You, the individual, were worse off, but your population exoded. This is the trap part. Once you do it, you can never go back. You're a hunter-gatherer tribe of 30. You accidentally become a farming village of 300. And now you have to farm. If you try to go back to hunting and gathering, 270 of you will starve. You are locked in. You are trapped by your own success. This is the foundation of everything. This new, unnatural system of farming creates the one thing the Ice Age never had: surplus. For the first time in history, one person can grow enough food for two. And that second person, that's the quirky tidbit. That second person is the soldier, the priest, the king, the scribe, the potter, the weaver. That surplus grain, stored in a communal silo, is the first form of wealth. It's the capital you need to pay for a professional army. It's the tax that a king can demand. It's the salary for the scribe who needs to sit down and invent writing just to keep track of all the grain. Our entire civilization, our cities, our kingdoms, our art, our wars, our literature, our phones, is a 10,000-year-old ripple effect from that one slow, miserable, bad decision. It's a decision that was only possible because the great 100,000-year cycle stopped, and this one long, stable, boring summer began. You're standing in that farming village 6,000 years ago. You're trapped. You're locked into this new, exhausting, but wildly successful system of agriculture. And the only reason you can do it is because the planet is letting you. The 100,000-year cycle that defined your ancestors' world is asleep. You are living in the long, stable, boring summer. But the clock is still ticking. The great cosmic waltz of Milankovitch never ever stops. The 100,000-year eccentricity, the 41,000-year tilt, the 26,000-year wobble, they are still pulling and nudging our planet right now. So where are we in that cycle? This is the mainstream historical fact that frames our entire modern world. We are, or at least we were, at the peak of a very average interglacial warm spell. Our current orbital setup is one of low eccentricity, a very circular orbit, which means our seasons are mild. It's a setup that naturally leads to a very long interglacial period. Based on these cycles, the planet should be starting the very, very, very slow, almost imperceptible slide back toward the cold. The cool summers aren't due for a long time, but the absolute peak of the warmth should, by all natural rights, be over. We should be, right now, in the first, gentle, 10,000-year-long autumn of the Holocene. But we're not. You check the geological thermometer. You look at the ice cores, the tree rings, the ocean sediments. The temperature is not going down. It's going up, and it's not going up slowly. It's not a gentle rise. It's a violent vertical spike, a hockey stick that has appeared in the last 200 years, an instant in geological time. The planet's ancient 100,000-year rhythm has been interrupted. It's been hijacked by us. This is the Great Interruption. Around 250 years ago, at the dawn of the Industrial Revolution, we discovered a new magic trick. We found a way to mine the ancient buried sunlight of a different hothouse world. We found the fossilized carbon from the Carboniferous swamps 300 million years ago, and we began to burn it. We found coal, and then we found oil, and then we found natural gas. And in doing so, we reversed the fundamental carbon cycle of the Ice Age. Remember the 100,000-year feedback loop? The ocean got cold, so it slowly absorbed CO2 from the atmosphere as a feedback. The CO2 level followed the temperature. We have flipped the entire process on its head. We are not following, we are forcing. We are taking millions of years of ancient sequestered carbon and forcing it at an insane, unprecedented rate out of the ground and into the atmosphere. We are, in effect, wrapping a new, thicker, man-made greenhouse blanket around the entire planet. The scientific evidence for this is not a debate. It's an atmospheric fact. It comes from the quirky tidbit of tiny, ancient air bubbles trapped deep in the Antarctic and Greenland ice cores. These are our smoking gun. We can drill down, kilometer after kilometer, and directly sample the Earth's atmosphere from 10,000 years ago, from 100,000 years ago, from 800,000 years ago. And in that entire 800,000-year record, through all the glacial cycles, the planet's CO2 level never, ever, went above 300 parts per million, ppm. It bounced like a heartbeat between 180 parts per million, the deep cold, and 280 to 300 parts per million, the warmest interglacials. That was the natural ceiling for our planet's warm state. When the Industrial Revolution began, we were at a comfortable natural 280 parts per million. Today, as you are listening to this, the level is 420 parts per million. And it is climbing. We have shattered the natural ceiling of the 100,000-year cycle. Let's put the speed of this in perspective. At the end of the last ice age, the Great Thaw, the planet's natural cycles raised the CO2 level by about 100 parts per million, from 180 to 280. That violent shift took about 7,000 years. We have added more than that in 150 years. We are doing in one human lifetime what the planet's grand orbital machinery takes millennia to accomplish. Scholars still argue, but not about if this is happening. They argue about the consequences. What happens when you take a system that is built to run on a slow, 100,000-year pulse and you shock it with a jolt of energy that is thousands of times faster and stronger than it is designed for? The answer is simple. You have overridden the Milankovitch cycles. The gentle astronomical nudge that should be slowly, eventually pulling us back toward the next ice age. It is irrelevant. It's a whisper in a hurricane. It's like trying to stop a freight train by blowing on it. The forcing from our own industrial CO2 is now so powerful that it has completely overpowered the orbital clock. We have, in a strange, ironic, and terrifying way, cancelled the next ice age. It's not coming. Not in 1,000 years. Not in 50,000 years. We have broken the 100,000-year pattern. We have knocked the planet out of its natural rhythm. We are no longer in the Holocene. We have pushed the Earth into a new, unknown, and unstable state. We are the new geological force. We are a new geological force. We have broken the 100,000-year pattern. But here is the lesson that, if you take away anything from this journey, must be this one. The 100,000-year cycle was never a story about ice. It was a story about instability. It was a story about tipping points. The single most important and terrifying mainstream historical fact that the Ice Age teaches us is that the Earth's climate does not change like a dial. It does not go, oh, it's getting a little warmer, a little warmer, a little warmer. It does not do slow and steady. The Earth's climate changes like a switch. It absorbs stress and absorbs it and absorbs it, showing almost no change at all until it hits an invisible, non-linear threshold. And then, in the span of a single decade, the entire operating system of the planet flips to a new state. We have seen this. This is not a fringe theory. This is not a model. This is the scientific evidence that is screaming at us from the past. The Younger Dryas was the smoking gun. It was the planet's great off switch. For 1,200 years, the entire heat pump for the northern hemisphere shut down. It did this because a single system, the Atlantic Meridional Overturning Circulation, or AMOC, was broken by a flood of cold, fresh water from a melting glacier. The Ice Age, then, is a history of these switches. The catastrophic draining of Lake Missoula. The sudden runaway albedo feedback that starts an Ice Age. The carbon cycle feedback that locks it in. The system is designed to jump from one state to another. And now, we are standing at the control panel. With our 420 parts per million, and counting forcing, we are running around the room, pushing all the same buttons that triggered the greatest catastrophes of the past. Only we are pushing them harder and faster than the planet ever did. Let's look at the dashboard. The AMOS, the exact same ocean conveyor belt that shut down the Younger Dryas. It is right now measurably slowing down. This is not a future projection. It's a present-day measurement. Scholars still argue over how fast it's slowing, or how close it is to its tipping point, but the data is unequivocal. It is weaker now than at any point in the last 1,000 years. Why? Because the Greenland ice sheet is melting, and as it melts, it is pouring unprecedented amounts of cold, fresh water into the exact same spot in the North Atlantic that Lake Agassiz did. We are, in effect, rerunning the Younger Dryas experiment, but we are doing it intentionally. Now let's look south. Remember the quirky tidbit of the West Antarctic ice sheet? WES. The one we talked about back in Section 12. The unstable one. The one that is not sitting on high ground, but is a marine-based sheet. grounded below sea level, where warm water can get underneath it. That is no longer a quirky tidbit. That is arguably the single most terrifying tipping point on the planet. The warm ocean water is getting underneath it. We can see it. We can measure it. The grounding lines, the points where the ice is stuck to the bedrock, are retreating inland year after year. This system is designed for a runaway collapse. Once it starts to go, you can't stop it. There is no off switch for this one, and the collapse of the Weihs alone contains enough water to raise global sea levels by 3 to 5 meters, 10 to 16 feet. This is what the Ice Age was trying to teach us. The ancient, terrifying machinery that ran the 100,000-year cycle. It's still there. The Mammoth is still there. The unstable WAIS is still there. The massive water-filled Greenland ice sheet is still there. These switches did not vanish just because we invented agriculture. We are now pushing the entire, vast, interconnected system backwards. We are reversing the 34 million year long cooling trend. We are forcing the planet out of its ice house state and back toward the hothouse world of the Eocene, the one with palm trees in the Arctic. We are seeing in real time the great ancient systems of the planet responding, not to the faint, slow, 100,000-year whisper of the Milankovitch cycles, but to us, to our forcing. We have woken the sleeping giants. So, what about the future? What about the next 100,000-year cycle? You're standing here in the 21st century at a profound, terrifying, and in some ways, strangely magnificent moment. You are a member of the first species in 4.5 billion years of Earth's history to understand the grand cosmic clockwork that built its own world. You are the first ape to look up at the stars, and then down at the ice, and figure out the math that connects them. You are the first being to know about the 100,000-year cycle. And you are, by a tragic and profound coincidence, the only species to have ever developed the power to break it. The great mainstream historical fact of our time is that the 100,000-year pattern is over. It's a relic. It's a story from the before time. The Milankovitch cycles are still whispering. The planet is still tilting. The orbit is still stretching. But it no longer matters. We have shouted so loudly with our own carbon forcing that the whispers of the cosmos are drowned out. We are now the signal. We are the new geological force. The 100,000-year rhythm of the Pleistocene is over. We have, by our own hand, pushed the planet into a new, uncharted geological epoch. Welcome to the Anthropocene, the age of humans. Our future, for the next 100,000 years, is no longer in the hands of the orbital clock. It is in our hands. We are the ones driving the bus, and we are driving it with our foot flat on the accelerator, backwards in time. This is the final mind-bending fringe tidbit that you must understand. The future we are creating is actually the past. We are not pushing the planet into a new state. We are forcing it back to a very old one. Remember our journey. Remember the world before the ice back in Section 2? Remember the Pliocene? Let's go back, one last time. It's 3 million years ago. Australopithecus is just learning to walk in Africa. And this is the world we are recreating. The scientific evidence is crystal clear. The last time the Earth's atmosphere consistently held 420 parts per million of CO2 was the Pliocene. And what did that world look like? It was warm. On average, 2 to 3 degrees Celsius, 3.6 to 5.4 degrees Fahrenheit, warmer than our pre-industrial world. There were no great northern ice sheets. Greenland was green. And the sea levels? Because that ice wasn't locked up, sea levels were, on average, 25 meters, 82 feet, higher than they are today. This is not a model. This is not a projection. This is a historical fact. This is where the planet naturally finds its equilibrium at this level of CO2. This is where we are heading. This is the future we are actively right now choosing to build. A future where every single coastal city on Earth, London, New York, Miami, Shanghai, Ho Chi Minh City, Amsterdam, Tokyo, Rio de Janeiro, is not flooded. It is gone. It is 100 feet underwater. This is the great, terrifying responsibility of our age. We are the first to know the rules, and the first to have the power to break them. We are, in a very real sense, the gods of our own epoch. And scholars will argue, for as long as we have a future, about what we did with that power. We are, in a strange way, facing the same challenge that our ancestors faced in the LGM. We are living through a period of profound, terrifying, and rapid climate change. Theirs was a great thaw. Ours is a great hothouse. But the challenge is the same, and the Ice Age has given us the 2 blueprints for survival. The Neanderthals showed us the first way. Adaptation. They were masters of it. Their bodies adapted to the cold. They were tough, resilient, and they endured. They took the world as it was, and they changed themselves to fit it. We will have to do the same. We will have to adapt. We will build seawalls. We will move cities. We will learn to live in a hotter, more volatile world. We must, because a lot of that change is already locked in. We are, in a way, the new Neanderthals. But that is not enough, because the Neanderthals lost. They vanished. They adapted, but they could not innovate fast enough to keep up with the new, disruptive software of Homo Sapiens. We are the children of Homo Sapiens. And our second blueprint, the one that is in our blood, is the one that won. It is technological innovation. Our ancestors didn't adapt to the cold. They hacked it. They bypassed it. They didn't grow thick fur. They invented the sewing needle. They didn't evolve stronger arms. They invented the atlatl. They didn't just endure the world. They changed their relationship to it with a new idea. This is the lesson of our 100,000-year journey. We are the species that innovates. We are the species that solves. We are the ones who can look at an impossible challenge. The -40 degrees Celsius cold, the giant bear, the saber-toothed cat, and invent a new tool, a new idea, a new social structure, like the first alliance with the wolf, to overcome it. We need both of those skills now, more than ever. We need the Neanderthals' grit to adapt to the changes we can no longer stop. And we need the Sapiens' spark of genius, that needle and atlatl moment, to innovate our way out of the rest of it, to invent the new energy, the new carbon capture, the new software that will let us hack the hot, volatile world we have created. The great 100,000-year cycle of the Pleistocene is over. The Anthropocene is here, and the clock is ticking. So we come to the end of our long, long journey. We have traveled 50 million years from a hothouse world with no ice to the birth of the great southern anchor of Antarctica. We have watched the planet's clockwork, the 3 grand cosmic motions of our orbit, begin to tick, first on a 41,000-year beat, and then, in a great unsolved mystery, on the 100,000-year rhythm that would define our world. We stood on the Mammoth Steppe, that lost magical carpet of grass and dust that fed a world of titans. We met the mammoths with their antifreeze blood. We saw the giant tunnel-digging sloths, the armored glyptodons, and the great saber-toothed cats who, in a strange echo of ourselves, cared for their wounded. We walked into the deep, dark, and sacred silence of the caves, and saw the minds of our ancestors, their souls laid bare in charcoal and ochre, their voices still singing in the resonant chambers. We saw the love and the mystery of the Ivory Princes, a grave so lavish it shattered our illusions of a primitive past. We watched the first great alliance, the pact between our ancestors and the wolf, an alliance that would help us conquer the world. And then we watched that world die. We saw it drown in the catastrophic continental floods of the great thaw. We saw it plunged back into a terrifying decade-long apocalypse during the Younger Dryas. And we stood on the graves of the last megafauna, the victims of a 1-2 punch from a changing climate, and from our own newly arrived, hyper-efficient spears. We saw our civilization, our entire, fragile, 11,000-year-old experiment, born from the one thing the Ice Age never had, a moment of quiet, boring, predictable stability. And now, here, in the final moments of our story, we find ourselves the children of that stability, having become a force so powerful that we have broken the clock. We are the new geological force, the new forcing, and we are pushing the planet, with all its ancient, sleeping, tipping point switches, back towards the hothouse that started our journey. But the 100,000-year cycle, the great, slow heartbeat of the Earth, it's still there. Underneath all our noise, underneath our cities and our carbon, the planet's grand, slow rhythm is still ticking. The Milankovitch cycles are still pulling at us. They are a force of nature so vast that they are, in the long run, indifferent. They are the true, deep time. The Earth's systems are ancient, and they are powerful. We have, in our infancy as a species, made our mark. We have scratched our name onto a single grain of sand on a beach that is billions of years old. The planet will go on. The story of the ice is, in the end, a story of resilience. It is a story of profound, violent, and relentless change, but also of the incredible, stubborn, and fragile journey of life that finds a way to endure it. And now, your own journey is at its end. The story is over, and all that is left is to let the images fade, and to ease into the quiet, the great, slow silence of the ice sheets. Let it go. The thunder of the mammoth herds, let it fade into the distance. The ghosts of the great bears and the saber-toothed cats, they are gone. Asleep now, back in their own time. The flicker of that first brave Sapiens fire, the one that held back the dark. You can let that, too, soften into a gentle, warm, and distant glow. All that matters now is the darkness, and the quiet, and the comfort of your own bed. The long 100,000-year winter is over. The long day of our journey is done. All that is left is the long, comfortable, peaceful sleep the long sleep.